好像刚说表定90。Good morning, everyone. Welcome to day 2 of ETH Taipei. I'm Teresa, your host for this morning. Let's get started with our first speaker. Please welcome Vitalik. And the topic is public goods, open source, and Ethereum's future.
Great. So Ethereum is open source software, and Ethereum fully and completely depends on open source software, right? So this is a list of open source projects that I found basically just by searching for it for about 10 seconds. And you can see just a huge number of different software libraries created by a huge number of different people, some of them in the Ethereum Foundation, some of them by companies in the Ethereum ecosystem, some of them by other nonprofits, some of them by independent volunteers, all of which are just a critical part of making the Ethereum ecosystem actually work, right? So if Ethereum was not open source, then first of all, nobody would trust it. And second, it would be much harder to make progress because like if the code isn't open, that just makes it so much harder for anyone else to come in and collaborate and build on top of what already exists, right? So we can also think about this by thinking about public goods, right? So, you know, in economics, we've talked about the phrase public goods for about the last 100 years or so. It's one of the major topics in a discussion about economics. Basically, if you have a project that benefits a large number of people, but where you can't like make some fine-grained choice of who gets the benefit and who doesn't get the benefit, right? So if you think of something like cleaning the ocean, right? You can't clean the ocean in such a way that if someone pays you 25 cents, they get the clean ocean, but if someone doesn't pay you 25 cents, they get the dirty ocean, because you know, there's one ocean. In a digital ecosystem, I think it's really important to like appreciate that the average project is a public good, right? So software in Ethereum is a public good, documentation, education, resources that help people understand what's happening in Ethereum and the other things that are being done in the ecosystem. These are all public goods. Research, academic research, cryptographic research, economic research, all kinds of research are public goods. Protocol development, so if someone figures out an amazing EIP that solves all of the scalability problems, then that's a public good. Everyone in the Ethereum ecosystem benefits from it, right? And so Ethereum crucially benefits from all kinds of different public goods. Now, we can compare these two terms, right? So the usual definition of public good in economics is something that is non-excludable and non-rivalrous, right? So something that provides a benefit to a large group of people, and so one person benefiting doesn't reduce the benefit that someone else gets, and like you can't choose who benefits and who doesn't benefit. And like this is the way that people in economics tend to think about the concept, and it's a meaningful category because public goods are a category of important goods that's often difficult to use regular market mechanisms to pay for, right? If it was possible to like clean the ocean in such a way that you would only see the clean ocean if you paid 25 cents, it would be easier, right? People would just do that, and they would collect 25 cents from a lot of people. But this is not how the ocean works. And also, this is not how the infinite garden of Ethereum works. Now, in practice, I think a lot of people also end up just using the word public good to mean like something which is good and something which touches the public, or sometimes even something which is good and something which is created by some kind of public entity, right? Which could be a government, could be a nonprofit. And so one of the challenges with the term public goods that I'll talk about is basically, you know, it does have some of these kind of challenges in its definition that can make it difficult to really be rigorous about what kinds of things are we supporting, what kinds of things are we not supporting. Now, we could also think about the term open source, right? So the words open source and free software, which are not entirely the same, but they're very closely related. They have about a 40-year history, and the Open Source Institute has an official open source definition. The Free Software Foundation has a free software definition, including the 4 fundamental freedoms. And basically what these definitions boil down to is the source code being open and you being legally free to use, redistribute, modify the source code, including commercially without discrimination, right? So the nice thing about these definitions is like the definition of open source, like it has teeth, right? Like you can't just go and say, oh, I built this tower and everyone likes this tower, therefore this tower is open source, right? Like for something to be open source, like there are specific criteria that it has to actually fill. So why do we care about both of these things, right? Because Ethereum's future crucially depends on open source, and it crucially depends on public goods. And it depends on these things for 2 reasons, right? And I think of these reasons as being one, direct value, which is basically that public goods are useful, right? So if the Ethereum blockchain did not have Ethereum clients, then the Ethereum blockchain would not be running, right? And the Ethereum ecosystem would basically be what it was back in 2014, where everyone was excited and like thinking about what they would do on Ethereum if they could, but the blockchain would never start. And eventually people would probably give up and like everyone would pivot to AI or something. So this is direct value, right? Now, there's also decentralization value, and this is also often really important, right? Basically, public goods outcompete proprietary and otherwise non-values aligned alternatives. So often, if an open public version of a thing or a solution to a particular problem doesn't exist, then proprietary versions of that thing will exist instead, right? So, if you don't have subways and buses, then everyone will use cars, and often cars are much less efficient, right? If you don't have open internet protocols, then everyone will instead use proprietary internet protocols, and proprietary internet protocols come with vendor lock-in. They come with a lot of centralized power being concentrated in a particular company. So these are the two reasons why these things are important. And because they are important, we need to fund them, right? We need to fund open source public goods. If they don't get funded, they do not get produced. But also, in order to fund something, you need to select for it, right? And you need to exclude things that are not it, even if they try to claim they are, right? So I think, like, as someone who's really been trying to support the public goods funding and public goods governance and all of these topics in Ethereum for probably the last 6 or 7 years, one of the things that I often notice is there's a lot of people who basically say, look, I made this thing, I made a public good. And then, like, you look into the fine print, you look into what that thing is, and you realize it's a commercial project, it has a company behind it, that company has a token, the same group of VC firms invested in it, they have 46% of the token, the lockup schedule ends in 4 months, and they're gonna sell it then, so the token price is gonna go down, and of course, before it starts going down, they yell about it to the public so that the retail buys it. And then if your application uses it, then you have to make this small group of people richer. And then often a small group of people controls it, and they can change the rules to be what they want, but they still call it a public good. So this is the thing that we do not want, right? And to me, like, one of the benefits of the term open source that I really like is it really captures well the things that we want, right? Like, generally, public goods within Ethereum that we care about, they are open source software or open source writing or open source academic research, but also it's the clear definition that sets like very specific and tough criteria that are resistant to manipulation, that are resistant to like everyone trying to push themselves into the category because it's better for their narrative. So open source is a concept that was invented and perfected over the last 20 or 40 years. In the context of a modern digital society and economy, it does have a couple of important weaknesses, right? I think one of the big ones is that there are risks of fragility and of abuse of centralized services, even if those centralized services get built on top of open source code, right? So if you imagine Facebook, open source, or let's say Twitter open source to the entire Twitter algorithm, all of its source code tomorrow, would that fix everything? No. Why? Because, well, the version of Twitter that is on twitter.com, or I guess now it's on x.com, like, it's run by one particular company, it's run by a particular group of people. That's the version. They have a database. They control who can send tweets and who cannot send tweets, and who has free speech and who loses their free speech because they insulted the wrong person. And it doesn't matter if there's open source code sitting somewhere in the corner, because there is this like one single thing, this like logically it's a centralized thing that there is a structure of control over, and that structure of control is completely commercial, completely centralized. So the AGPL, the Ethereum General Public License, this was a license created about 20 years ago. It was actually created in part because of these exact concerns, right? Basically, what the license says, it doesn't quite solve this problem, but what it does do is it say, well, you're required to open source the code, not just if you create a derivative work and you try to sell it, but also if you create a derivative work and you try to run it as software as a service, right? And so it solves some problems. It expands the set of conditions under which you have to open source code if you build on top of it, but it also is far from solving everything. Also, open standards and interoperability, right? So this is another type of lock-in, is if you have one application, and then that one application has standards that other people cannot interoperate with, and then those standards potentially, like if a company wanted to be really evil, they can keep changing to try to lock competitors out. So last year, I wrote this post that was on making Ethereum alignment legible, and I gave a set of criteria for what Ethereum alignment might look like. And one of the goals that I had is to basically make this concept of being Ethereum aligned that a lot of people seems to care about into something that is not just a social game where you are Ethereum aligned if you are friends with the right people, but you are Ethereum aligned if you fit a particular clear set of criteria. And so one of them is open source. One of them is open standards, so using public standards, using the same standards as everyone else. If you have to create your own new standards, do that in collaboration with other people instead of just going off and doing it by yourself. And also decentralization and security, right? So like I have two tests here. One of them is the walk-away test, right? So the walk-away test basically says, if your company and your servers and all of its infrastructure just instantly disappear, will users still be able to get their assets out, get their data out, continue using the application? Right? And this actually matters a lot, right? So imagine, for example, you create a wallet, and then for your wallet, you use, say, ZK email to do a recovery for the account, but then the way that you use the ZK email, like the actual recovery flow is depends on like an interface that is part of the wallet, and then there's like no, it's not done in a standards compliant way, and like and so if your wallet becomes unavailable, then like the user can't use someone else's interface, and like you haven't even provided any alternative interface, and so the user actually doesn't have the resources that they need to actually be able to recover their account, because in theory it's controlled by your email. In practice, it's kind of bottlenecked by this piece of interface code that you wrote and that you didn't really put anywhere else. So the insider attack test basically says, if your team itself tries to attack the system, they basically they should not be able to steal your data and your assets, right? And so we saw, for example, with the Bybit hack, the limits of the resistance of the safe wallet to the insider attack test, right? Which is basically that the smart contract wallet passes the test, the interface does not, right? And so now there's a lot of work being done on actually putting UIs on-chain, doing on-chain versioning, and like things that really increase that kind of security. So another area where open source is not enough is open source has to get funded, right? And today, in the Ethereum ecosystem, open source gets funded by the Ethereum Foundation, it gets funded by a few other organizations, but there is this open question, right? How do we create a self-sustaining flywheel, right? How do we create a self-sustaining ecosystem where you actually have projects succeeding because of open source, and then some of the value of that success actually flowing back into the next generation of open source so that the cycle can continue to happen, right? How do we make that flywheel work without depending on a centralized organization with a limited budget to keep using that limited budget in an unlimited way? And also, like, what about other aspects of doing the right thing, right? So, you can open source software that can help people on the internet identify what's true and what's false, or you can open source software that makes it easy for people to like spam the internet and social media with even more misinformation, right? Like, open sourcing a thing is not automatically good, especially if the underlying thing itself is not automatically good. And so, like, also, where in this whole thing, like, categorization do we actually think about these kind of aspects of doing the right thing that aren't just about openness, right? And this is one of those places where, the language of public goods really does apply, right? So, if you put, like, substances in the water, then maybe the substance that you're putting in people's water is fluorine, and then there's like one kind of debate about whether that's a public good or a public bad, or that the substance that you're putting in people's water is like chemical pollution, and in that case, you're obviously making a public bad, right? Whether something is a public good or a public bad depends on whether the thing is good or if it's bad. So with open source, like, the difference between good things and bad things doesn't get included in itself, but like it has to exist somewhere, right? And so in this Ethereum alignments definition, I have I added these two other criteria, which is being positive sum and being positive sum toward Ethereum users, and also positive sum toward the broader world, right? So the Ethereum ecosystem should not just exist for its own benefit, it should also exist to provide broader forms of value to the wider world, right? And so these are things that I think we all care about, right? But then I think the interesting question is, how do we create more mechanisms to ensure that our ecosystem supports the right kind of open source public goods in a long-term sustainable way, right? How do we do this in such a way that these things do not just depend on a small number of organizations that have one-time pools of money? How do we actually create these kind of robust long-term institutions that can continue funding these kinds of things for the next years and for the next decades, and continue finding new sources of funding so that these things can continue happening, right? Like, I think Ethereum should be an ecosystem where we work on resilient and long-term solutions to make sure that this shared infrastructure is being funded, right? Like, Ethereum, I think, basically since the beginning, it's been an ecosystem where we really care about things like decentralized governance, right? We care about DAOs, we've cared about like things like quadratic funding, we've cared about how to like govern things like oracles for DeFi protocols. We've built, a lot of people have been enthusiastic about building like various forms of digital companies, digital nations. And I think for all of those ideas and that enthusiasm to get somewhere, I think like basically we should start with Ethereum itself, right? We should start using these ideas to really try to improve the state of funding and maintaining all of this open software and public infrastructure that the Ethereum ecosystem itself maintains on, and basically make the Ethereum ecosystem itself an example of this entire like social and economic process working in a sustainable way for the long term and working well. So thank you.
Thank you, Vitalik. Okay, thank you. Up next, we have a panel, OSS and funding mechanism. Hosted by Vivian Chen from Pagoda, with panelists King Ko from Litecoin and Yuki Kawabe from Code for Japan, and Nithai Harihar from VoiceDeck. Let's welcome Vivian, King, and Yuki Nithai.
Hello. Hi, everyone. My name is Vivian, and I'm the moderator of this panel today. It's really nice that we actually have our panel following the introduction by Vitalik, talking about public goods funding and open source funding. It has definitely been a topic that we've been contemplating a lot in years, right? For people here, like definitely years. So the panel today, we're gonna dive deeper into different projects that are actually doing public goods or open source, how they get their funding, what are the mechanisms that's created to support them, and what are some dilemmas that we can unpack within this area. We have a very diverse group of people here on our panel. I'm from Taiwan, have been involved in the civic tech or open source community and also Ethereum community within Taiwan and Asia. And then we have Yuki from Japan. We have Kin from Hong Kong, and we have Nidhi from India. So it's gonna be like a Asian-wide open source and public goods discussion, and you'll hear different projects too. Before we start, to dive into the discussion, I would like to invite all of our panelists to talk a little bit about their projects. What are you working on right now, and how is it connected to public goods or open source? Would you like to start, Yuki?
Okay. Hello, everyone. I'm Yuki from Code for Japan. Code for Japan is a nonprofit organization which is doing civic tech and open source software community. So civic tech is a local activity which is we are using technology to improve our daily life with technology, and we also collaborating with local government and national government to adapt new technology to their daily operation. So, and we have our 11 or 12 years history for the open source community in Japan, and we are actually as Myanmar's earthquake, we are collaborating with them for the like mapping project. So yeah, we are building a lot of open source in the decades. Thank you.
Yeah, so before we go into Kin, I just want to mention that what COVID Japan, them actually started with earthquake. And then just want to recognize, like acknowledge the fact that last week we actually just had a really big earthquake across Asia, mainly in Myanmar and Thailand. And that the earthquake actually happened when the four of us were having a call. And I was in Thailand, so our call got cut off, it was a whole power outage, and we couldn't continue for a little bit, but then we resumed the discussion. And after that, Code for Japan, they actually volunteer to support the open source map building for Myanmar earthquake. So these kind of effort in itself, during crisis, during disaster, where human actually need support from other human, is also where open source kind of public goods projects can be of service. Yes, and then we have Kin.
Hi, I'm Kinko, who's mainly involved in two projects. One is Litecoin, which targets to open, to decentralized publishing, and in particular, decentralized books. And the other is DHK, which is to decentralize or defend Hong Kong. I talked about it a little bit on the DX day, on the other day. And of course, it's all open source.
All of the things you do with Likerland, Litecoin, or DHK, both very open source.
Yeah, it's open source as far as like coding is concerned, but DHK is not much about, there's not much tech in it. We mainly do civic education. We are trying to bring 7 million people on chain, and we don't do much development. We are more using the open source tools for that purpose. But as far as content is concerned, it's all Creative Commons when its data is open. But then for Litecoin, it's an open source project, 100%.
Yeah, so what Kim mentioned about like having some part of the content being Creative Commons, that's actually also another mechanism to support not fully open source, but some part you need to be credited, some part you want people to refer to. Sometimes you cannot let people use your thing. So Creative Commons itself is also kind of a tool to support people when they want to open up their projects. And Nidhi?
Yeah, I'm just feeling really grateful and proud that to be sharing stage with Kin and Yuki and Vivian, because all of these technologies that we're building is so rooted in real world communities, challenges, and that's what VoiceDeck really stands for, and VoiceDeck was born out of that. My husband and I, we worked as a journalist, and I'm an urban planner. We worked in villages in India, and we found that non-profits in India were having a tough time raising funds because their marketing wasn't as great. English is not our first language. And so because of that, funding to these organizations would happen only if you know someone who knows someone and you know how to speak the language and have a sexy looking report to give. So VoiceTech actually turns that around. We fund organizations solely based on the impact that they have already created. So we retroactively fund that based on the outcomes an organization has created. And we are open source as well. In fact, in some very good news, we have another project called Gainforest that recently forked our repo, and they are now funding environmental impact, and they're running an entire round in the GG23 community round now. So really standing for all of these open source technologies that are furthering public good or real world, addressing some real world challenges here. So really happy to be here.
Yeah, I think what's really significant is that a lot of the project within public goods or open source space is actually very deeply connected to local and real world issue. While like a lot of people has been looking for solutions for, not solutions, for looking for problems for your solution, for your tech tools, these are people that are actually building specifically for a set of problems that are run into in real life. And can we talk a little bit about the problem that you guys are trying to solve? I think Yuki, you mentioned that Code for Japan has been working on like civic tech specifically, and also working with local government. How did that start? And then what is the problem, the real world problem that you are trying to solve with all these open source projects?
So, fortunately, the Japanese government are more are interested in the civic tech and the open source software, and they are actually supporting us. But the hard part is how to motivate the citizens to continually joining our activities. To continue doing the same thing, we need motivation and the power. But if there is no incentives, the activity will go on, like in 1 year or even in 6 months. So this is one big problem for the local government. If they invest first 6 months, but after that, the activity is not continuing. So we are making project called Toban, which is retrospective rewarding to the community to continue. If the community continuing the project and make some value in the society, the government can fund retrospectively to the community, and they distribute the rewards to each members. This is we are right now we are really focusing on.
Okay, so Code for Japan right now building this tool called Toban, trying to see how government funding can be a funnel into these open source builders who has already been contributing to open source project, public goods project on the ground with Code for Japan, solving real world Japanese issue. And government, if they see the effort, they can retroactively fund the effort that these builder has been doing. Amazing. What about Litecoin and DHK? Like, what is the problem you are trying to solve? And then, is there any like similar problems that you run into when running your projects?
Yeah, so for Litecoin, we are trying to decentralize books. So, like, although books has become like from paper to electronic books, but then some people may not realize electronic books are somehow even more closed than paper books, because when you are so-called buying an ebook, you are not really buying, you are just like renting. The platform can go away, or the platform can censor your book, and you don't really get it. And so we are trying to build a so-called debook protocol. So, and we are encouraging book publishers to use Creative Commons with relative success, because like everyone is trying to protect their IP, so to speak. And anyway, we're trying to make every book an NFT, so that things go, the metadata stores on chain, and the book itself stored on IPFS and Arweave. So that's Litecoin. And for DHK, let me quote a few examples. So we do what we call a drifting classrooms, which is the like somehow pop-up classrooms in marginalized cafes. So people can come and create their wallet and get a DHK token, so that we are trying to bring people on chain like one by one, hand in hand. And we do what we call Uber, which is Universal Basic Reader, which is to collect the Hong Kong books, which was banned, removed it by the Hong Kong public libraries. And we try to do that in a decentralized way. So it's curated by independent, like a set of independent bookstores. So it's not like curated by a particular person, not by me or not by the Hong Kong government. And publicly funded as much as possible, because there's a whole list of books that's worthy to be kept and collected by Hong Kong, which documents the Hong Kong history. So people see the list and they can help to buy the books. And we keep it in a public place so that people can. It's essentially a library, but we cannot call it a library, like for legal concerns.
Got it. Can you actually expand a little bit on the Universal Basic Reader program? What does that mean, and what is that project?
So maybe I have to provide some background. So in 2023, so 2 years ago, the media found that a lot of books are being removed by the Hong Kong library. Said they're being censored, but we don't really have the full list, because it's not like they have a list of banned books. If they do have, it would be easy, but they don't really have. So all we can do is like, I remember I once borrowed this book from the library like a few years ago, but now that it's gone from the record. And so the first thing is to crowdsource what books are being banned, which is already hot. So there are like 500 of them, but I'm pretty sure the actual number is way greater than that. So that's the start. And then we try to find these 500 books and have them scanned it, if the publisher allows us to do that. And afterward, I think it's too passive, too reactive to just react to ban the books, remove the books, because new books are not being removed by the public libraries anymore, because they just don't collect it, so they don't have to remove it. So we just go ahead and try to buy all the Hong Kong books that's newly published. since Hong Kong books is being defined by by Hong Kong, for Hong Kong, or of Hong Kong. It doesn't have to be published in Hong Kong because a lot of Hong Kong books are published in, say, for example, Taiwan these days for obvious reasons. And and it's hard to say all the books because there are simply too many. So someone has to curate the list. And we have a set of independent bookstores to come up with the books that they choose, month by month, and have the public help to buy them. Yeah. And the rest of them, the outstanding books that are not purchased by the public, will be brought by the DHK DAO. So that's the project.
Thank you. So now you can see that with these public goods projects, there's actually kind of a pattern of how decentralized, how by people, it's actually it's basically the way it's formed. And in contrast to the very centralized way, either big government, big tech company, or whatever bigger authority is doing, it's like actually a contrast of people versus the power, and people actually gaining the power again through the process of having open source as their tools, having public goods supported so that they can continue their action. Nidhi, with that, can you also explain, give us an example? How do you support journalists or any project that through VoiceDeck, is there any success story that you can share with us? How do you, or mechanism like VoiceDeck can support the actual real world people doing their project?
Right. So VoiceCheck actually solves for two major challenges. One is what I call the banker-teacher value problem. That is, in our societies, a corrupt banker is paid much more than a teacher in a village. Why? Why is that? Because the value given by a teacher is, you can't quantify that, you can't have any value to that, but it is very useful. So what VoiceDeck does is solves for that value problem in the sense that public goods are goods that capture a lesser value than they give. And so we're trying to, through VoiceDeck, our funding model is basically bridging that gap between value capture and value given. And secondly, in our work with nonprofits, we also felt like there is a need to create new impact in any society. Whereas the nonprofits we were working with, we were recycling the same impact, like if we were working with slums 10 years ago, that same project was being sold to Bill and Melinda Gates Foundation or another philanthropy. So there is no incentive to produce new impact because you're just churning that the same impact out. And that's why VoiceDeck's model of funding is basically it closes that wheel, like Vitalik just mentioned in his talk now, that self-sustaining flywheel of raising money, creating some impact with it, and that impact generating more revenue to create new impact. So that flywheel of impact is what VoiceDeck is doing. So for example, on our platform now we have listed a story by citizen journalists in central India. For example, women were not allowed to enter a particular temple in central India because women are considered impure because of menstrual cycle and so on and so forth. And this woman in the village reported this issue, went didn't leave any stone unturned in reporting it. It caught the attention of the local government and police and everything in the area. And now, because of her reporting largely, the women are allowed to enter that temple. So we list that on our platform, and you can buy units of that impact directly. That's a very different experience of donating, because right now if you want to donate and you go to any organization, they'll probably just tell you, okay, whatever you see fit, if it's $10 or $500, you just give us anything. We are having a different model for that. We feel like the impact of a story should be priced at a fixed cost, like a t-shirt. It's like buying a t-shirt. You go pay $500, you get the t-shirt. In the same way, you pay, say we have a fixed cost for each of these impact reports, and once that cost is reached, you can't fund that that particular report anymore, which incentivizes people to just move on to the next, to creating the next impact. So that flywheel of impact is really important.
Thank you. So, creating sustainable, self-sustaining flywheels for different projects is actually how these like funding mechanism has been trying to achieve. Like, how do we design different mechanisms so that people working in real world on the ground can actually get funded? That's actually how, like for a lot of us, how we got into, say, Ethereum or like blockchain in general. With the design of Ethereum, there's like already incentive design within the mechanism to support people to contribute to the ecosystem. And that itself is a very fascinating model where actually a lot of the project on the ground has been trying to see how they can either duplicate or learn from the Ethereum model to see how that can be duplicated in the real world. I would like to ask all of you, since what you're working on is so impactful and so important for the ecosystem, how do you, your organization, get funded?
So, yeah, I think we have three model. One is this is a main our organization is kind of job. Like we are supporting local government and national government to adopt new technology as a consultation. So we are making money as a business for that part, and we invest all the money to get from the job to the community activities. This is one part. And second is we are getting fund from the um, foundation in Japan, and we apply. We Code for Japan doing a lot of things like climate change, to survive the disaster, and also the disinformation, misinformation, and maybe how to use the technology to local. So we have a lot of projects, and we are submitting the fund with each project. So we don't submit as a Code for Japan. We put every single project. So this is the second thing. And the third one is we are fostering to collaborate with Asian countries. Like we have Facing the Ocean, which is a hackathon event we are hosting with Code for Korea and Gab0 in Taiwan. And each nation have a motivation to engage the international collaboration. So we can, not only the Japanese government, we can collaborate with the other countries to get funds from the other countries. So this is the third one.
So what Covert Japan has been doing, very interestingly, is been working, even though they are almost sometimes replacing the government, as in doing the job government should be doing, but also they're collaborating very closely with the government, so that government has an alternative way to also support the effort on the ground. Kin, how is your project funded?
Yeah, so we had a round of token sale in 2018. We don't have VC, and the money of the token sale has been like, of them has been used it for a few years actually. So I'm mainly funding it by myself for now, and a little bit with Geekon grant, not much. So sometimes we jokingly said it's sponsored by Satoshi, because I'm mainly selling the Bitcoin that I have to fund it for now. And for DHK, we have a newsletter, weekly newsletter, which is in Creative Commons, so we don't have a paywall, but we encourage people to subscribe it and become a voluntary pay subscriber and fund the DHK initiative. And also, as well, like Gitcoin grant as well. So, which is probably around 20% of our income.
Oh. Just wonder, I'm not sure if everyone here is like familiar with the Gitcoin mechanism. Kin, would you like to explain a little bit how Gitcoin works?
So Gitcoin grant is like for funding the public goods. They still call it public goods. So I'm not sure if they require the projects to be open source. I think they prefer, but probably not a hard requirement. So they have different tracks. Say the latest track, the latest campaign is Gitcoin Grant 23. So it's the 23rd round, and with a focus on, say, open source project, OSS project, and Litecoin is one of them, so that people can do micro donation and have their donation matched by some matched fund sponsored by sometimes Vitalik or sometimes other bigger projects.
So
Sorry, forgot to mention. So usually calculated by QV.
Yes. So we've actually just we hosted around our community, the Asia Community Pagoda. Last year hosted around Asia, it's called Asia Round, basically supporting all of the open source public goods related project within Asia. And the way we do it is that we collected matching fund from GCC, Global Chinese Community. They're a community supporting public goods projects across all Asia, around the world, and focusing on the Chinese-speaking community. So we have funding from them, and we have another funding from Gitcoin itself, and formed a pretty great, like 75K matching fund. And people can put their projects on Gitcoin platform, and when people donate to each of the projects, they don't only just get the donation directly from the people, they also get matched with the funding pool that we already prepared, the 75K. So each of the money, like all of, like say donor donated to, the value is actually extended because it's on the Gitcoin platform, because it's using the quadratic funding mechanism so that it can be amplified. And this is like one of a very classic funding mechanism that's being used within the space. Nidhi, what about VoiceTech?
Yeah, I mean, Gitcoin for us was the introduction into like blockchain in one way. I mean, we also use hypercerts to create those impact certificates and generate that flywheel. So that use of blockchain was there. But really like Gitcoin grants and even the GCC, I mean, rounds, I'm very grateful we were recipients of a grant from them. And we really appreciated that because quadratic funding gives you some non-zero amount of money, like it's okay, even if it's like $100 or $200, it's like worth it. But right now, we get like 70% of our funding from Gitcoin rounds. And we have recently also started expanding this funding mechanism of ours to other ecosystems like of funding open source software, like deep funding. There's going to be a talk on that right now. Basically, anything which requires you to fund any organization, any project based on the value they give, that's what VoiceTech stands for, and we're doing that with deep funding as well. And now with the new community round in GG23, there's a Gainforest round. It's hosting a round especially based on this funding mechanism. So those sort of contracts give us some funding as well.
Yeah, so funding mechanism, there's like, it's like a complex system, right? So VoiceTech, Toban, or Litecoin, they fund like the projects that are related to their sphere, but also them themselves need to be funded. So like in a bigger like ecosystem, who support them so that they can support like the on the ground people, and if they support organization, they also need to support like downstream, like actual people working on the thing. So it's like the free will actually need to consider all these different cycle, all these different level of people organizations involved in the mechanism. When we were having our call, actually, Kin put up a pretty valid point, I think, within this within our prep call. A part of it is definitely about creating this self-sustaining flywheel. It has been very challenging for many of us because you can see, like, Kin basically used his pocket money to support the continuation of his project, and we rely so much on grants or government funding or different things. And that makes people feel like we are nonprofit. And but the framing of being nonprofit associated with open source or public goods is actually not that healthy, right? Kim, do you want to explain a little bit on your concern with
May I
that?
mention one thing?
Yes.
Right now, actually, the Gitcoin Grants 23 is happening right now. I think tonight we'll start the new round. So if you are interested in, please go explorer.gitcoin.co. Then maybe you can find
Support us,
us.
support us.
You can put the $1 or $2.
Oh, I guess all of our projects are, are on Gitcoin. Yes, so go to Gitcoin, support them. Yes, coming back to our question, Kim, do you want to explain, like, what is the dilemma you are facing between the self-sustaining flywheel and nonprofit?
Yeah, I had an issue. Like people tend to have a binary will between profit-making projects and like public goods. So they expect public goods to be non-profitable and not self-sustaining, which which makes sense. But which also means if you are trying to create a business model for public goods, or you are trying to create a so-called flywheel, sustaining flywheel for your public good, people would like kind of don't know what you are. People or they would see it. So you are a profit-making entity. So I'm not going to donate to you, which makes it very embarrassing. So and you don't know who you are. I mean, you know who you are, but people don't know who you are. People don't know. It's actually a good thing. I mean, if public good projects, open source project can find a business model, but on the way of doing it, you would kind of lose your identity. You would kind of lose your attraction for people to support you because you are a public good. Because people would see it as a commercial project, and they don't see why they have to donate to you. But at the same time, you are not as competitive as 100% commercial project because you have double bottom line. You have to take care of other values other than just making money.
Do you have similar problems when you're running your project?
I mean, that's the challenge we began solving for with VoiceJack, because most of the non-profit media outlets we worked with had to raise grants through the normal process, had to apply for it and had to know English and do all of those things. But VoiceJack really is trying to bridge that dilemma in some way. Because all you have to do is basically just focus on your work and create impact and do impactful work, and just rest assured that the funding will be taken care of and you can move on to the next impact. So in fact, deep funding is also another offshoot of this, and because it takes into account the dependency graph as well. So like what you were mentioning about us depending on other forces to fund us and we funding these other organizations. If basically deep funding will just map all of that on a graph, all the dependencies, and then you algorithmically just distribute funds according to what value each project has given. And so I feel like VoiceJack is basically an attempt to bridge that dilemma by just funding the value, by just funding the impact.
From the Taiwan or Code Japan perspective, anything you want to add to this specific dilemma?
Oh yeah, for quickly, So for the large number of people, I think in Japan it's enough to do for the open source software, but for the local government, like small number of people, they not enough. So how we can care about the small communities. We are in the decreasing of population, and we are seriously taking care of the problem. So in that case, how we can support small group. For the large number of people, we can support as a business, but how about small? Maybe it's like a same as like circulation of the entire ecosystem in the nation for someone.
I think before we close this this panel, this whole discussion here is actually a reflection. I would like to encourage everyone to reflect with us, like, why is it so difficult to support projects that are actually beneficial for the public? Why do commercial, like quote unquote, commercial projects get so much funding while like people on the ground are actually facing problem being self-sustained when they are doing the work that are actually open source? They can have legacy, they can have like really good impact on people, but they are struggling. This has been kind of a dilemma that we've been talking about. Maybe that's a problem with what the framing of business. Maybe it's the over commercialization of our social structure. But with Ethereum, coming back to like our topic and basically our whole day, is that Ethereum itself, it creates possibilities, or these mechanisms create possibilities for people on the ground, people like actual contributor, not just coder, but also the mechanism can be duplicated to real world system. It's a possibility for on the ground people to get funded, to get supported through like very direct value distribution. And that's what many, like all of our panelists basically are doing right here. So we have like 2 minutes left. Any last word you wanna, like last piece of message you wanna send to the audience regarding this funding mechanism, open source, and the dilemma and everything?
I think the flywheel is not only for the sustainable funding, it's also the population of the people of the project. So if you are interested in, let's join the open source software and join on the public good stuff. Yeah.
Flywheel, not only for financial resource, but also human resource.
Yes,
Different kind of
exactly.
resource, all need its value, its flywheel to actually have people have resource to continuously contribute. Kin, any last message?
Well, like you kind of conclude too well. So I can only like encourage everyone to pay more attention to all the open source and public goods projects and involve them as much as possible.
Thank you.
I'll borrow this from my husband, who's also the co-founder of VoiceJack. Jesus said that, punish the sin and not the sinner, and we should fund the impact giver, the impact and not the impact giver. So, yes.
Beautiful. Thank you. And before we go, last thing, since like our call happened when the earthquake between like Myanmar and Thailand happened, that's also like a funding mechanism issue. Like a lot of the funding people are donating to through government or through larger nonprofit, they don't really go to people on the ground doing the actual rescue work or really providing supplies. So if you're donating for the Myanmar or Thailand earthquake, any relief activities or effort, please support on the ground nonprofit. Verify when you donate so that you can make sure that money actually go to the people that that really needs it. I think that kind of concludes our, sorry using this for little promotion on the right thing to do. Thank you. And then thank you all of our panelists, Yuki, Kin, and Nidhi. Amazing projects. Continue the good work you're doing. This is our panel. Thank you for staying with us.
Thank you. And please drop in a penny or two for all our projects in the Gitcoin round.
Yes, go to Gitcoin.
Thank you, Vivian, King, Nihai, and Yuki. Next, let's welcome Devesh Mehta from Ethereum Foundation, leading AI public goods and governance. The topic is deep funding. Oh, they will pass it to you.
Oh, the slides. Yeah. Okay, I'm gonna press this and next one. Hey guys, thanks for staying for this talk. I'll be presenting on deep funding, which is how can we use AI to give money to public good projects and to open source software. We see a lot of efforts around how can we make AI give money, but this is like the first effort from like the EF and Vitalik and others to do this in a very thoughtful way and a thoughtful manner. So kind of this is just, I'm going to like lay out the context. Kind of like right now we have funding sources and contributors, and it's just like very exhausting to go through all of the projects in a Gitcoin round and give money to 500 projects is very exhausting on a juror. So kind of there's this idea of guilds. So something like Protocol Guild is an example where of a level 1 guild where you give money to Protocol Guild and it distributes it to contributors based on time that they have been contributing. What we are trying to do with deep funding is a level 2 guild where the money goes to an AI which is chosen through a competitive process, and that AI gives money to the repos and then repos give it to the contributors. So we are trying to create that for funding things. So how do we do that actually is the question. So this is kind of just the difference between what traditional public goods funding is and what we are trying to do. So kind of the biggest problem I say is that in all of public goods, only crying babies get fed. That unless you're crying loudly and and telling all your friends, you don't end up getting money. Which is not how it should be, because a lot of the good people who are working do not want to be marketing or crying, so we need to really solve that problem. The second is quantity over quality. That, I mean, if any of you have been jurors over here, how many of you have been a juror and sat on committees? Like, hand? Anyone sitting on committees, jurors? So kind of something you would realize is that you have to go through 500 applications, and it's very tiring to go through so many applications. So kind of how can we focus on quality over quantity? That we only look at 5 projects or 10 projects, and somehow that then gives us ratings on all 600 projects. So as a juror, I only want to vote on 5 projects. I do not want to vote on 500 projects. That's kind of a feedback we've got. And yeah, like rewarding all projects for value, like for the value provided, and algorithmic distribution of funds. We don't want to be putting brown lipstick on our face, and then because we've like kind of made the right people happy, we get money. I think that like all of us don't get a good feeling that I got this grant because the person giving the grant is my childhood friend. Like that's not how it should be. So this kind of in a brief is what deep funding does, where it's a machine learning competition. So all of you need to submit AI models which give weights to the repos. So we have about 15,000 edges in the graph. So you have to give ratings to all 15,000 of the repos that are there. And level 1 is like the core consensus clients. So things like execution clients, consensus clients. You have to try creating an AI model which gives weights to A plus B plus C plus D so that they're equal to 1. Then you have to decide how much money stays with the repo or how much goes to its dependencies. So if you look at something like Brave browser, it's actually a fork of Chromium. So Brave has done very little original work. The majority of the credit belongs to Chromium. So the second step is deciding how much stays with Brave browser and how much should be passed on to its dependencies. And the third step is just making sure all the dependencies get added up to one. So basically you have to submit an AI model which gives values to A, B, C, D so that they're equal to 1. An AI model which decides how much should stay with B and how much should be passed on to its dependencies. And the third is an AI model which B1, B2, B3, B4, B5, B6 is equal to 1, all of the dependencies. So that's kind of what we're asking contestants to submit. So this is like a very cool graph of all of the different dependencies of Ethereum. So these are all of, like, these repos are what makes Ethereum succeed and what makes it run. So kind of in just one sentence, if you need one takeaway of what deep funding is, the one sentence I want you to remember is that your job is giving how thick are these lines. You see the lines in the graph? So this is an unweighted graph. We haven't tried to make a decision that is Web3 JS more important or is Remix more important. That's not a decision that we are making. That's a decision we're telling the community to submit an AI model to make. And then so your job is just deciding how thick the line has to be. How important is one repo versus another. So how do we decide which AI models are good and which AI models are bad? Assume that everyone in this room has submitted an AI model trying to decide how thick the line should be in that graph. How do we now decide who is the winner? Who is the winning model that gets to now allocate money? So this is where we have comparisons by a jury. So actually Changwu over here is a juror. So he gets to like give a few ratings. So he will make some ratings like, is Fabel more important or is ESLint more important for consensus Teku success? So what I said about jurors wanting to focus on quality and not quantity, Changwu will only need to actually record like 30 of these comparisons. That's it. Even though the full graph has 15,000 comparisons, all he has to focus on are 30 of them. And we'll use his 30 comparisons to select the AI model which is most similar to his preferences and to the other jurors' preferences. So all the model builders are trying to understand what is the jury going to vote, and they will try to submit models accordingly. So the jury only submits 30 comparisons, the model submits 15,000 ratings, but we use the 30 comparisons to select the aligned model which is most similar to the juror. So that's kind of how the competition works. This is maybe the end output of what deep funding will result in, where you have these different projects and you have different weights to the projects. This example is just based on GitHub stars, so don't take any of these numbers seriously, but it's like indicative of what an end output might be. That you put money into one public key and it gets distributed to all of these repos in this ratio. So something like Remix gets 15%, something like Hive gets like 0.6%. So it's like very programmatic. You know, this is the end output of what deep funding might result in. A graph with all of these different repos and how much weights they get. This is a really cool example of kind of like Vitalik made this to show the ideological influences on Ethereum. So if I just run you through this graph briefly, you have Ethereum in the center, and then you have the level 1 dependencies right around Ethereum. So things like the open source software movement, the cypherpunk movement, Bitcoin's monetary policy, all of these have impacted Ethereum. So the things right next to Ethereum have to add up to 1, that all of those influences. Then we decide that if we take Bitcoin's monetary policy, how much of it is original and how much does Bitcoin's monetary policy have dependencies. So in this example, Vitalik says Bitcoin's monetary policy is 1/3 as important and 2/3 is the dependencies of Bitcoin's monetary policy. So some things like Austrian economics is 37% responsible for Bitcoin. Marx's labor theory of value is 2% responsible for Bitcoin. So kind of if we wanted to put money into this graph, you can just put money and it gets distributed to like Bitcoin. If you put $100, Bitcoin's monetary policy would get $6, and Marx's labor theory of value would get 25 cents, and Austrian economics would get about $4. So it's a very programmatic way of like funding public goods and entirely through dependency graphs. So these are like I'm reaching the end of the deck. So now I'm going to talk about 3 challenges that are there. So there are 2 ways that you can get involved. One way is if you're an AI or machine learning or even just like a model builder, you can take part in all the challenges we have. So if you go to deepfunding.org, you can get taken to the challenge page. This challenge is on for another 8 hours. Like we talked about the Gitcoin round that's happening. So this is a super exciting challenge where people have to predict the results of the Gitcoin round before it begins. So we have 700 projects or so which are taking part in GG23. You have to build a model which is going to tell us how much money will each project get in the round. Then submissions will close in 8 hours once GG23 begins, and then we let the round run, and then we see at the end of the round which model best predicted how much money each project is going to get. So like we have prizes for this. First place is $5,000, second place $3,000, third place $2,000. So this is a really cool challenge, which is very meritocratic. Are you able to predict how much money a project will get in GG23? And the purpose of this is if the error rate is low, like if the top model's prediction and the actual results are very consistent and very low, then we can decide how much money a project should get without them even taking part in a Gitcoin round. So they won't need to market themselves or anything. We can just use the top model in this competition to say how much money should this project get. And the model will give an answer and we can just give them that money without them actually having to take part in Gitcoin rounds, which is cool. This is the deep funding challenge. Oh, sorry, this is the old challenge. So we looked at past funding data and we asked people to predict how much money they would get. And we finished this competition. We declared the winners. We got 21 high quality models submitted. So we had 21 submissions. We had a jury which included Vitalik and Carl Caravone and other good names. And that jury went through all the submissions and they selected winners. And this was like a competition that we just finished about 2 weeks ago. And finally, this is the third competition, which is the deep funding challenge. Like here, you have to submit predictions on how important 15,000 different edges in the graph are. So there are 5,000 open source repos. A few repos are used in multiple places. So the full graph is 15,000, which you have to give a weight to. So that's the deep funding challenge, which is also open. You can also submit a model for this. So GG23, you can submit a model in the next 8 hours. And for this one, you can submit in the next 1.5 months. This is going to be taking long, but this is super impactful. This is going to kind of channel a lot of funding towards open source repos, the deep funding challenge. Yeah, so this is like kind of the team that's made it possible, the entire deep funding work. Kind of something which is interesting is that a lot of these teams have been working on these issues for years, and kind of my role was just bringing all of these teams together. So Open Source Observer made the graph that all the participants are using to submit their answers. Pairwise has been working on comparison voting. So we've used that for the jurors to give their ratings. Drips gives money to open source repos. We're using them to distribute money to them. Pond is running the machine learning competition, cryptopond.xyz. So that's the platform for all the model builders to submit. So actually by bringing all of these partners together, we could make the whole greater than the sum of the parts, which is how you actually do experimentation in this space. Like at the EF, we don't want to be the ones creating these mechanisms. We want to just be the people who are bringing everyone together, and then the whole becomes greater than the sum of the parts. Yeah, you can join the conversation. You can scan this QR code. be part of our Telegram group, take part in these competitions that we are holding. Kind of the main KPI that I've set for myself at the EF is how many of these machine learning competitions that we hold, where the community is competing with each other and we are actually declaring that this model is better than this other model based on the ground truth data. So yeah, we have a lot of cool competitions coming up. If any of you are interested in AI and ML stuff, like this is your chance to kind of prove that you're actually good at it and you aren't just a talker. So yeah, excited to see what's coming up and kind of hope that you all find this deep funding challenge inspiring. There's 3 ways you can take part. One way is by submitting a model in the deep funding competition. Second way is by becoming a juror and submitting votes on how important repos are to Ethereum. And the third way is by giving funding through the deep funding mechanism. So if you're interested in any of these 3, please get in touch. Yeah.
Thank you, Devish. So to close this session, we have our last panel, AI and Public Goods, hosted by Zoe Chen from ETH Labs. The panelists, Devish from the Ethereum Foundation and Tammy Young from Numbers Protocol. Let's welcome them.
Hello, it's a long morning. So today we're going to talk about AI and public goods, and I'm your moderator today, Zoe, and I'm now leading a digital identity research lab with Moda, and I previously worked on RPGF mechanism designing, and that is related to public goods. So I think that's what makes me here moderating this session for you. And before this morning, like Vitalik talked about the open source and Devansh talking about deep funding, and now we're picking up the threads talking about AI and public goods. So I would like to introduce like 2 of our panelists here. Devansh, I think we kind of like hear a lot of from you, like from earlier keynote speech. So Tammy, why don't you introduce yourself to the audience?
Hello, good morning. I'm Tammy, the founder of Numbers Protocol. Nice to meet everybody here.
Okay, is there any recent activity you want to share from Numbers Protocol to the audience? The workshop.
Yeah, so I think we actively having a lot of information, a lot of activities like a workshop and also to engage with the community and promote the provenance. And I will talk more about the provenance of content and in the later conversations.
Yeah, so Tammy, your work rooted deep in journalism, and you're providing a tool that like help the journalism, like you provide a blockchain for them. So what do you think that public goods in your domain is like? Are you building public goods?
Yeah, so I think, so before I start answering the question, I think just a few background for the journalism project that we have worked with. So previously, for the audience who are not very familiar with how we use the blockchain to support the journalism, and previously we leveraged the blockchain technology and also Web3 technology to support the journalists in States and also in Taiwan to create the provenance of the digital content and also help them to monetize their content better to have a global network. And the next phase will be leveraging what we're going to talk today to create the AI models. So I think the reason why we are working on this and also related to your question is I think in our domain, the journalism and the reliable information and the graph which connect all the dots. So that's how we define the public good, because only if we may have a a good information graph where everybody can rely on, and then we can have a resilient communication. We know how to verify the information. So when you talk to me and when we are having the information, and then we know what to trust, and even if we don't trust, and then we know how to track and how to verify the information. So that's kind of the foundation of our everyday life. So before we talk about blockchain, before we talk about Web3, because before we talk about all these technologies, so the key is the communication of our society. So that's how we define, the information network, a reliable information network, and also the truth. And that's how we define as a public good in this domain.
Yep, thank you. So, Devansh, do you want to share the story about the start of deep funding?
Yeah, I think that's like a good story time, kind of thing. And I like my biggest advice to people is to just tweet every day, like be active on Twitter and share what you're building. Kind of the archetype of a coder who just goes and builds his own thing and then he comes out and it's an amazing thing he's built and everyone recognizes it. That's not how things work. Like while building it, you have to keep sharing your journey. So while I was working on Voice Deck, kind of one of the things we're interested in is AI quantification of impact, that how do we have AI quantify how much impact has been made. So I just tweeted this out and Vitalik saw this tweet and messaged me saying, hey, I've been thinking of something similar. And he kind of lays out the entire deep funding mechanism. And so that's how deep funding became a kind of offshoot of Voice Deck, that deep funding is a smart way of quantifying impact. And that's how it started. Like, after I tweeted about it and then 5 days of conversation, and then he's like, okay. And Vitalik said, okay, we've reached the end of our theorizing. Do you want to like now just go ahead and do a pilot with it?
Yeah. So based on your previous work in journalism, like you were previously a journalist, and your current work at Ethereum Foundation, do you think, and now currently this deep funding project, do you think that can benefit other open source community or other ecosystem as well, not just EF?
Right, so I think the idea of like dependency graphs lends itself well to open source software because it's so easy to figure out what are your package dependencies. So kind of to give an example, like something in companies, like the reason companies always outcompete networks is that they can integrate their cost center and a profit center. So if I take something like Twitter, Twitter has an ad division, which is earning profit, and they have something like community notes, which is a cost center. It's not earning profit. But because they have an executive, they can take money from the ad division and give it to community notes to make a better product. But in open source software, we do not have this integration between cost center and profit center. If Aave is earning money, they are a profit center. If Solidity is creating the smart contracts which Aave depends on, they are a cost center, but there's no easy way for Aave to give money to Solidity, even though it's a dependency of theirs. So I think deep funding can be a way to integrate your profit centers and your cost centers so that we can actually start competing with corporates and some of the centralized corporations that are currently kicking our ass.
Yes. So I think previous panel, we talked about how hard MPO or open source project get funded. And I think with Deep Graph, like there are a lot of open source repo on GitHub. So if we can figure out how heavy the dependency on with those repos, I think that can be really beneficial for those developers online. And let's get more specific right now. So if we want AI to be reliably built and fund those projects, I think we don't want to reinforce the current power or the current hype. And what infrastructure do we want to build and fund, and what's missing in the current space? So Tammy, do you think the provenance can become a critical input of AI, not just in media domain?
Yeah, I think that that's exactly true. So I think currently, so when you see a piece of content, a piece of information online, and everybody rely on the declaration, right? So just like if you put an image or you record a video, and then you may claim, hey, this is created by me, and this is owned by me, and then this has been created at this time, and then so on. And I think in the future, so like when AI is going to support us in a lot of domains, and it will be actually very terrible if AI cannot tell the story behind and it cannot have the reliable information. So if you imagine the reliable information the reliable content as a node of the big network, and also the source of it, or the conceptual nodes as the edge to point back to the the origin of the content, and then it start creating a big graph where you can rely on. And I think that kind of network is going to be very important for building the AI in the future. So that kind of network and the big information graph where you can verify and then you can track and the age of it and the nodes of it, and you know who runs it, and it's transparent, and that's going to be a very important infrastructure in building the future AI.
Yeah, thank you. I think information graph is definitely important in the journalism world because the truth, it's one connected to another, right? So, Devansh, I think the deep funding mechanism, while I'm doing my homework for this panel, I heard that there are 3 metrics you're using to evaluate all the repos and like how you give those scores, and there are 3 components working together. One is the jury, human, and one is the model, and one is which one is another?
And the other is the graph itself.
Yes.
Yeah. So, yeah, you have 3 components. You have the graph, which people need to train, which people need to give answers for. That this is the graph of 15,000 repos. Now you have to give numbers to it. The second is people who are building the models, giving the numbers. And the third is the jury. And the instructions we give the jury is to vote on like specificity, that is this specific to Ethereum, or is it like is it a dependency which everyone uses? Additionality, that is this repo already well funded, or is it something which can actually use the money well? And the third is replaceability, that if this package dependency didn't exist, how much time would you have to spend on it? And like talking to your earlier question about like building resilient infrastructure for AI, I think the future which I want to see for AI is where AI is like similar to a fruit seller, where if I don't like a fruit seller or he's charging extra money, I just go to the next fruit seller who's like more competitive and I can get it. So in like the deep funding case, if people have submitted an AI model, but someone submits a better AI model, then kind of we take the weights of the better AI model, and better is defined as aligning with the jury more, aligning with the humans more, which the jury is submitting. So that's the world I want to see, where like today this AI is on top, but then tomorrow someone submits a better model and then that AI comes on top and then the weights change.
Yep, so I think in this case, I would think the model is part of the public goods, right? So how do you evaluate that? So do we want to govern that? And how do we fund them in the future? And Tammy, for you, I would like to ask that if there's a model embedded in your infographic system, like what is your imagination or in your roadmap, what could that be?
Yeah, so before answering that question, I also want to respond to your previous comment that the information graph is very important to the journalism, and that's exactly true. But also I would like to add that it's actually affect all of us. So take the reasonably image the hype, for example, like if your lifelong efforts can be very easily stolen, and then you don't have the motivation to work anymore, because if you keep creating the creative work, and that could very easily be learned by the AI, and then in the end, then people will not have the motivation to keep creating, and then it means that AI will not have the new data. So I think it is in the future network, what we imagine is that the information network is just the first step, because it provides the links to the content and its origin, and also the history of it. So once we have that, and we will be able to have the AI to properly credit the information source. And so it's not just about the misinformation problem, a fake news problem. It's not just like that, but it's like related to all of us. When we are the creativity provider, when we are the information provider, can AI in this network working in the way that it will credit the information source, probably not just providing the information saying that, hey, this information is provided by Reuters, this information is provided by another journalist, but also like working in this network and can probably properly reward the people who are behind this piece of content. And then once the people are the human are also rewarded by providing quality and also the reliable information and the content. And then they will help AI to learn better and knowing more about the story behind. And then that will create a smarter and also a more responsible AI future.
Yep, thank you. Devansh, do you want to add anything to it?
Yep.
Model is public goods.
Yeah, and like the AI models and how we fund them.
Yeah.
Yeah, so like by and large, we rely on the wisdom of the crowds for getting AI models. I think the idea is that like one person sitting in his mother's basement can like make an amazing model, which like even outcompetes companies. And we've certainly seen that with DeepSeek, which kind of operating on a shoestring budget has made something which has even taken like the Western world by storm, and OpenAI and others have become scared. So I think so that's one part of it, that you try to keep the competition open for anyone in the world to submit a model. And then the second question becomes, how do you give prizes to people who are submitting good models so that it actually becomes worth their time? And kind of like, so Vitalik has made the scoring script for deep funding. Like he coded it up himself. Like within 2 weeks, he just like made this entire Python script by himself. And basically what it does is that it combines the best out of various models to create a mother AI. So assume that you submit a very original model. Like Zoe submits a very original model. So Vitalik's script will say that 20% of the mother AI is from Zoe's model, 10% is from Tammy's AI, and 5% is from Devansh's AI. So the eventual leaderboard is how much are you contributing to the mother AI. And we can then give money through that as well. That Zoe is contributing 20% to the mother AI, so she gets 20% of whatever we want to give the model builders. So it becomes a very clear way to fund those who are making original and good models.
Yes, so I think besides the model, the dependency graph is also playing a vital role here. But there is a controversial question I would like to ask, is that how do we have human jury, but how do we know that AI is not ignoring those messier but vital project repo out there? Like in the model, can we actually find them? Like how do we discover those messier projects?
Yeah, I think this is something which even Tammy can talk about, which is about biases. Like how do we kind of, when people are writing, how do we just not keep replicating biases? And I actually think AI is better over here, that if there's some unexplored repo, which none of us have heard about, like AI is still going to be neutral with respect to that repo, whereas you and me are going to like be preferring like the well-known repos which we've heard about and like ignore the ones that we've not heard about for the most part. So I think that's one good part of it, that AI does not discriminate based on reputation. AI models will look at like hard metrics and how much is used and other things like that. Of like where the bias does enter the picture is the jurors. Ultimately, we want AI to be trying to predict human judgment, and human judgment itself has its flaws. So one of the flaws is like what I call the halo effect, that even, and we actually saw this in deep funding. So I'm going to give you like a cool story over here, which is that there's a repo called Web3.js, which has done a lot of good work for Ethereum in the past, but it's been overtaken by upstarts like Veeam or Ethers.js. They've taken over all the share which earlier Web3.js had. So the jurors actually gave a very high rating to Web3.js, saying Web3.js is great and it's like got good, it's done good for the ecosystem. But like simultaneously, there was an EF investigation which found that no one is using Web3.js anymore. So I'm like looking at the data from jurors and I'm seeing high scores to Web3.js. I'm looking at the report from the EF, which is saying no one is using Web3.js anymore. And I'm like, how do these two things map together? So Web3.js is now discontinued, and this was the backstory to it. So there is a problem with human judgment over here, and AI can't AI can help mitigate it, but these are inherent problems with human judgment.
Yes, so talking about this, I wonder that whether the verifiable content and the provenance metadata can be part of the dependency graph or your future, like, more evolved infographic in the future.
Yeah, I think so. I mean, like in the recent days, it almost like every day, and then you have the new AI tools, the new AI features. So everything is changing very fast. So I think in the coming future, the way how we provide the content. So like previously, I was talking about the content and then also the information graph, and there are provenance of the content in this graph where you can rely on. So I think at the beginning, so we probably will think about that content is maybe just an image, a video, a post, or a document. But I think in the coming future, it may be slightly different because the way how you provide content, your content. So just like it could be that the journalists, so they are the content source, and all of them build their own AIs to provide the information. So in that way, it's not like connecting the content and the content verifying the provenance of each file, but more like connect the AIs and the AIs, and then they are all part of this big graph, and then they provide the knowledge to the bigger AI. So in that case, I think the role of provenance remains the same because it tells you like how this AI is generated and what type of data content has it already consumed, and then who is in charge of this AI, and then and so on. So only when like each small AI are all responsible, and then the information they provide is verifiable, and then eventually you could form a bigger network, and we can call it the information network or like information AI network.
Yep. So this graph we're talking about mostly about content and media, right? So Devansh, do you think the dependency graph will in the future have the domain-specific dependency graph? Because now it represents it's growing from the core Ethereum repo. But do we want, as this ecosystem will get bigger and bigger in the future, and that will be more harder to evaluate whether that's public goods, how big is the impact in the ecosystem. Do you think we need like a domain-specific graph in the future?
I think it's a question of like where, like, so I think we see two problems over here. One is the credit assignment problem, that for Ethereum, how much credit belongs to this repo versus another.
Yeah.
And the second part is like the funding loop, that where is the money going to come from, which is going to be given to this graph. So I think like the domain specificity will come in once we have the funding loop. So if there's something like IPFS, it's a decentralized file sharing network. They have money coming in from Filecoin. So if Filecoin wants to reward the IPFS dependency graph, then it makes sense to create one separately for IPFS. For Ethereum, we have like fees coming in or something else. Then it makes sense to create like the Ethereum dependency graph. So all deep funding is actually doing is solving the credit assignment problem. Like we are figuring out how much credit belongs to A versus B. But that's only one part, and the larger part is like where is the money coming from, which is then going to be divided according to credit. And I think that's what I also find cool about numbers protocol, that kind of the graph work of like knowledge, we can eventually then apply the deep funding mechanism to even like the knowledge being produced by people. So things like citations and things like what you're working on and you're linking back, all of that, it can be applied to other domains there too.
Yeah, I think that concludes this topic a little bit. So next, I want to talk about some risks, because if you're bringing AI into your ecosystem, there must be bias and risks and responsibilities we need to talk about. So since we're using models to allocate funding and helping human make the prediction and even govern future DAOs, so do you think the model can be biased to a point that they are somehow not only, but incentivizing those projects are doing private goods, but rather than public goods? Yep, the model bias.
Yeah. So I think it's good to have many models for this reason. Like initially, like my thinking initially was, we will create this one model and we will feed it good data, and this model can tell us all the answers. And that's exactly what like Vitalik pushed back against, and that's how he opened up my mind, that we don't want just like one AI overlord who we all hope for his beneficence and his generosity of the AI. Like we instead want many AI models, and each of those AI models are competing, and then we have a selection process to choose the best AI model. So I think that's like a much safer future where we have competition and we don't just have kind of a lock into one AI model.
Yeah, that's good. So you're leveraging like multiple models to balance this ecosystem. So tell me, in your ecosystem, I think I saw on your GitHub repo that a lot of repos are public, and there are some forks as well. And how do you maintain this provenance system like more like in an inclusive way and more transparent in your own ecosystem?
Yeah, I think so. Having a little bit more blockchain record would probably the first step, and that's also what we do at Numbers Protocol. But I think so. This is actually referring to or experience in the last 6 years while building Numbers Protocol. I think this is actually a very complicated topic because it's actually related to how the trust that you build. So if something is completely transparent, do you just 100% trust it? So I mean, let's say, for example, like if a politician like claim that so everything, so all the works is on trend. So I think so some politician in Taiwan is already trying to do that, like creating the blockchain record and then putting everything on trend. So and then in that case, do you believe them already just by having everything transparent? So I think that's a very good first step. But eventually, so I think we kind of like as a member of the community, we need to have a kind of just like keep growing the system and then providing the incentives to people. So that's why I think the funding program is very good so even though there could be bias at the beginning, but I think eventually if we could make sure the incentives and all the fundings are towarding the right direction to encourage people to put more efforts on the public good instead of the private good, and then put more efforts on really reliable information instead of the not reliable information or the private information. And then in that case, I think we have a better opportunity, but not guaranteed, but just a better opportunity to build a more reliable and transparent AI future.
Yep, thank you. I think to wrap up this panel, we talk about the mechanism, the risks, and the responsibilities. And then next, I think we want to talk about some call to actions to the audience. So one thing I would like to ask first that how can we become a jury? Or is that selected at the moment?
Yeah, you can apply to become a juror. Kind of what you need is like familiarity with the core Ethereum repos and what its key dependencies are. So if you have that familiarity, go to deepfunding.org and there's a link called Become a Juror. So you can click on that and apply, and we review applications and add you to the juror pool. So that's kind of on the jury side. And if you're an AI or ML model builder, like you don't need any of our permission, you can just go submit a model. And if it aligns well with the jury tags, then you will be kind of rewarded and given glory as well. Yeah.
Yeah. Tammy?
Yeah, so I think for the call to action, I think so this year and then probably starting from last year, I think there are actually a lot of provenance related to activities on the internet. It may not all related to the blockchain. For example, like there is a very big framework called C2PA, and it's already on LinkedIn. And then I think it will be soon on Meta and some other social platforms as well. So I think the one thing I would like to encourage everybody to try is that, so if you are seeing the content online, and then maybe it's interesting to just verify its origin and before you have any feeling or emotion or even the decision. And I think that would be very interesting. And also our numbers protocol. So we launched the numbers protocol about 4 years ago, and of course, 4 years ago, AI was not yet like having a significant impact in our daily life, but now it's completely different. So like this year, we're also going to have like an update of everything we have, including the GitHub repository, the website, and then to build an environment where everybody can more easily to be involved in this movement. Eventually, I think people are still the most important and the most crucial part in the AI future.
Yeah, thank you. So I think we have still like 5 to 10 minutes left. I would like to open the floor to the audience. Is there anyone who wants to ask a question? Whether it's about numbers protocol or deep funding? No? Yes? Okay, then I think we're going to wrap this up earlier, and then you guys go to get some delicious lunch, Taiwanese lunch in that hall. So yeah, thank you. Thank you, everyone.
Thank you.
Thanks again to all our amazing speakers. Let's wrap it up right now. Don't forget to come back at 1 p.m. In the afternoon, we have talk from Cello, Nethermind, and more. Enjoy the lunch at Building F and rest of ETH Taipei. Thank you.
All right, good afternoon, everyone, and welcome back to the conference. Glad to see so many people, actually. I was almost not making it as well because the food was so delicious. And also the music. Cool. So first stop, let's welcome Fully from Baseline to talk about Uniswap Unstable by Design. Welcome.
Everybody. Okay. My name is Fully, and I'm here today to talk about. Actually, it's not Uniswap. It's XYK liquidity. So I realized that last night when I was making the slides, and I didn't want people to think I was like shit talking Uniswap. I think they're a pretty good protocol, but I do have some problems with the V2 implementation that they have. It's actually very like commonly used. AMM. So this talk is specifically about how XYK is probably not the best liquidity structure. It has nothing to do with Uniswap. But yeah, let's get started. Okay, so I kind of want to get a gauge of like people's familiarity with this topic. So just by show of hands, do people know? How many people know like what XYK is or have heard of it? Okay, so like decent amount. Yeah, so for those who don't know, XYK is like a type of automated market maker, helps price liquidity on DEXs. And it's actually the most like adopted on-chain liquidity curve that we use today. So if you did any kind of DeFi farming in 2020, if you've ever done a swap on chain, if you ever bought a meme coin on pump.fun, all of those things probably use the XYK curve, and so you actually interacted with this, maybe if you didn't know it. And the way it works is actually very simple. So in this pool, when you make a trade, this curve will just price your trade based on how many tokens it has in the pool. So when you say XYK, X refers to one side of the token supply times another side of the token supply. That creates a constant. And so when you do a swap, you just have to make sure that the K stays the same when you change one of the supply numbers on the side. So like for example, if we have a liquidity pool, it has 10,000 USDC and 200 tokens in it, then K would be 10,000 times 200, which is 2 million. So if someone wants to buy 2 tokens, then you take the 2 million, which is the constant, you divide that by 198, is the number of tokens that they're taking from the pool, and you end up with 10,101. So in this example, someone would be paying $101 to receive 2 tokens from the AMM, and they would get an average price of like $50.50. And so that's generally how it works. First, I kind of want to talk about why it's good, because it's the most commonly used thing. Everyone uses it. And the reason comes down to simplicity. So the nice thing about AMMs is they're very simple. You just put the tokens in, and the whole system will handle the liquidity distribution, the liquidity rebalancing. You never really have to worry about managing a position. It's just gonna generate fees for you, and it's a very passive strategy. So there's other alternatives out there today. There's Uniswap v3, there's order books and things, but people don't really use them because you need to set up systems to integrate with them, to rebalance them. So yeah, XYK is a very passive strategy. But I would say aside from that, there's actually no real other benefits. Being simple is probably its only strong suit. But it actually has a lot of problems, and we'll go into them. So the first problem is that this curve is very dumb. What I mean by that is the way that liquidity is provisioned actually has, they don't know anything about the tokens that they're selling or buying. So the XYK curve is just a math equation that defines a kind of arbitrary invariant. It doesn't know like the tokenomics, the market cap of what it's trading. And it always has to assume, actually, that there are infinite tokens that it can be buying and selling at any given time. And because of this, it means that there's always going to be liquidity in this XYK pool that will never ever be used. So even if every single token is sold into one of these pools, you'll actually find that at the very end, there's actually going to be some money left over in the pool, and that money belongs to nobody, so it's kind of wasted. And you see this with like pump fund coins. If you guys traded meme coins, even if all the billion coins get sold, you'll see like 6-7 SOL in the pool left over for every single pump fund coin that's deployed, and it's because of this curve. And so, on a small scale, maybe it's not a big deal. It's 1 or 2 pools, but over a large aggregate, like industry where almost every coin has a V2 pool, it's actually a lot of money wasted because it doesn't really know what's going on about the liquidity that it's providing. Okay, so it's not just dumb. The other problem with that is it's very lazy. So XYK is a very passive strategy, as I said, but it doesn't react to things that are happening in the market. So it only worries about how many tokens it has at any time, and it doesn't take into account, recent volume, recent price action, volatility. So it's not very market aware of the behaviors of the people that are trading with it. And I think that becomes a big problem as, markets are getting more advanced. Maybe in 2020, it's not a big problem. People are just trading, doing whatever. But now that we have like real institutional players of like real significant flows, and at scale, this is starting to become a lot of issues, the leakage, right? So because it's a static strategy, it's very easy to manipulate and to game this liquidity system. The common things that we see a lot is there's like sniping and bundling. So the XYK pool will just gather a lot of the liquidity at the very beginning of the launch price. It makes it really easy if someone's coming in, you're doing a fair launch, for someone to just snipe up the entire supply. You saw this with meme coins as well. There's like a lot of bundles. People started talking about it. Oh, is it bundled? Who bundled it? And it's because of this liquidity curve that allows that to happen. Yeah. The other issue is MEV and arbitrage attacks. People are able to clip out the prices on the pool because it's very static. It doesn't respond to the outside price adjustments. So until someone comes in and takes the free money, it's not going to update its price. And also, the other issue with this is it's very easily exposed to Oracle attacks because the liquidity is super thin. It's easy to manipulate the price with not a lot of capital. And so recently, I think a lot of people, if you trade, you saw like Hyperliquid had to delist a token called Jelly Jelly. It's traded on an XYK curve. It's a very thin curve. And so they're able to, do some price manipulation on that. And so even, some of the best projects can't really avoid the issues that this curve presents. Okay, and I would say the third issue with XYK is that it's very inefficient. It spreads the liquidity evenly across the entire curve. So I kind of talked about this before, how there's always going to be a little bit of that money left over. But the other problem with this strategy is that you have a lot of money sitting in the pool, but it's never ever going to get used for any purpose. It just sits there. It's completely wasted. To me, it feels like, with these pools, you have, you built a highway, and this highway has 6 lanes, but you only allow cars to drive through one of the lanes, and the other 5 lanes just sit there for everyone to look at and not use. And, a lot of times when you're trading in these pools, that's what it feels like. Okay, so the reality is we've been using this curve for basically everything that we've done in crypto. And we talk a lot about how, crypto coins are very volatile. Things kind of, always trend towards zero. And we blame a lot of people for a lot of things. Investors or the team is rugging. And I'm not saying that these things don't happen. But I also think that, we have to look at what's facilitating these problems in crypto. And to me, a lot of it comes back to the XYK curve. Because if you're trying to do the DeFi, staking yields or rewards, and you're trying to sustain the value of those emissions, and you're doing this on this price curve, it's going to be very hard for people to create sustainable economic models when they don't have the right liquidity infrastructure to support it. So it's kind of tongue-in-cheek, but the solution is potentially a project that I'm working on called Baseline. And what we're trying to do is we're actually trying to have a liquidity management system that's as simple as XYK. So you just deposit tokens in, it auto rebalances for you. It's a passive strategy. You never have to worry about your pricing, but it has a little bit, more intelligence as to how it's calculating the liquidity, right? So one of the things that we're gonna try to do in Baseline is we deploy liquidity with more awareness about the tokenomics of the system. So instead of just saying, oh, how many tokens do I have in this liquidity pool for the price? We actually think about what's the circulating supply, how much of it is currently in, outside the liquidity pool that we need to buy back in order to create something safe and create price ranges that help balance out that volatility. So with something like Baseline, you can actually calculate the exact amount of liquidity that's required to buy back the entire circulating supply of any token. So you can know, like, okay, this is the minimum value that we can guarantee in the liquidity pool. We can be more aggressive about defending certain pockets of value and things like that in ways that Uniswap doesn't know. And I just want to kind of give some ideas of what this might look like in theory. So one of the things that we've done is we've actually run simulations, trading simulations, where we deployed a Baseline liquidity pool and a Uniswap liquidity pool with the same starting parameters and run some trading against it to see how the price charts will look. So in here you see that the blue is the Baseline price and the red is the Uniswap price. Both pools start with 40 ETH of liquidity and 200,000 tokens in this simulation. It's 20% of the total supply into the pool with 1 million total tokens, and we're running the same trades for both. So you can kind of notice that in the second, with the blue, the volatility is kind of dampened, something you notice right off the bat. You don't have as much of the spiking on the top, near the top of the trades, and then as the price cliffs off, it's obviously not a fun chart to look at because nobody likes to see the numbers go down, but what you do see is that the liquidity can be buffered much higher, and so the ending price is a little bit better than the Uniswap pool. But then there are other things about this, I think, that make it interesting that you don't see under the hood. So for example, on the right side is the supply of this simulation for both the pools. So it's not just the price that's really interesting. If you notice on the supply with the Uniswap V2 curve, by the end of the trading simulation, there's actually still some surplus tokens that it has sold. So it's been net dilutive to the market, about 30,000 tokens extra. Even though the price has dropped all the way down, there's still extra tokens that people bought that they need to kind of sell back to the curve. And then in the Baseline system, we started out with a higher, or we ended up with a higher price, but we also actually created a less supply by the end of the trading simulation. So we did a net buyback of about 50K tokens in the pool, and for a total difference of about 80,000 tokens. It's almost 8% almost of the entire supply in terms of supply difference. Just from the curvature change in the liquidity, we're able to create this better price action. And the last piece that you can see is, I would say, the liquidity depth on the bottom right of the chart. This is just showing what percentage of the supply you need to be buying or selling to move the price 2%. So how much slippage do you actually get? And we're able to consistently provide higher and deeper liquidity than the Uniswap curve. We lose less money in the pool for doing it. And a lot of it just comes from the fact that we have more knowledge about how many tokens need to be traded and can be traded because we have the supply and the tokenomics in mind. And so that's just a quick simulation. What does this actually mean for you, and why is it important? Like, why do I care about talking about this? And the reason is because if you trade crypto, it means literally more money in your pocket. So when we did an ROI simulation, the trading simulation was done with about 50 different randomized agents that would have these randomized volume on certain conditions, bullish, bearish, and chop market. And we were able to find that if you take the ROIs of all of these agents at the end of the trading simulation, you'll find that on average, Baseline pools generate more ROI, both from an average and a standard deviation. So in a distribution, more people make more money from trading these pools. And the maximum ROI also is higher for Baseline. And so you can see that the liquidity of the pool is actually determining the outcomes of the market participants that are trading in it. And so if we want to have, better projects, more success with our tokens, I think this is something that we actually have to look at more deeply and think about more deeply. And then I don't know if we have time for this, but I just show it really quickly. This is one of the things that we have in production. It's our token. Again, it's another chart that goes down, so not that great to look at, but it's really important to highlight something here, which is that we recently, in a token we've launched called Yes, it was around 51 million market cap. We had someone sell, I think, almost $2.5 million in a single day, and the price went down about 15%, which is not great, but in this case, our project is still running and it's still smooth. If we used an XYK pool, the price would have tanked by almost 65% instead of the 15% that we experienced. The market cap would have less than halved, and I think a lot more troubles would have come from that. So it's cool to see this kind of like price action in production. Yeah. Okay, and that's all the time I have for. So thank you very much for coming to my talk. If you guys want to learn more about like liquidity systems and what we're doing at Baseline, feel free to scan the QR code and give us a follow on Twitter. Thank you very much.
Thank you, Fuli. And yeah, next up, let's welcome Drew about why have we given up on algorithm stablecoins. Ooh, like today we're like full of controversial and fun topics, right? This is awesome, awesome. Let's give a round of applause, sir.
All right, hello everyone. My name is Drew. I work on Pinto. I'm on the founding team of Pinto, which is something very similar to an algorithmic stablecoin, although I don't normally use that term because I think it deviates from expectations a little bit when people hear the term stablecoin. Today I'm not going to talk about Pinto though, or myself really. Instead, I'm going to talk about the more meta level of algorithmic stablecoins and why we've given up on them as an industry. So the reality right now is that everyone hates algorithmic stablecoins. It's really visceral when I go around these conferences or in real life and tell people what I'm working on and use the word algorithmic stablecoin. People react very poorly. They get pretty tense. Maybe they start tweaking. And then they like take on this defensive posture as if I'm gonna reach around and extract the value from their wallet on the spot. There's just a general sense that anybody working on this is a scammer and is just here to create a Ponzi scheme and take value out of the system. And I think this is a real tragedy, but I understand where people are coming from. There was a lot of pain in 2021, 2022 around algorithmic stablecoins. People lost a lot of money, the industry lost a lot of value, and there were a lot of very serious consequences. But before that happened and before that trauma set in, people really did believe in the mission of algorithmic stablecoins. And there was a sense that this is a very important concept to be working on. And so I want to talk about how we went from this idea of algorithmic stablecoins being a holy grail of crypto to sort of being this taboo that nobody wants to talk about. So to better understand this trajectory, I'm just going to talk really quickly about the state of the game with stablecoins on chain. Stablecoins are really important. It's very easy to see that they're really important. Right now, there's $220 billion of stablecoins on chain, which is a pretty massive number. For context, that's pretty similar to the total market cap of Ethereum, which I think everyone in this room would agree is a pretty important asset class. So we see that the market really values stablecoins, and there's no theory required there. It's very much the data is on chain. And so of all of this $220 billion, pretty much everything falls into two categories. These centralized stablecoins and these decentralized stablecoins. The centralized ones come with all of the existing problems of centralization that we know and love, the problems that we all are here to try to resolve. These ones are censorable, they require trust, and they're subject to the governments. And basically all of this value is inside of these two main tokens, USDT and USDC. So basically there's two actors and one or two governments that are controlling a huge portion of the value on chain. And I contend that this is a major problem. This really sucks. This is not good enough. Basically, we have this incredible tech stack, meticulously designed from the ground up to be decentralized and free us from the traditional constraints of financial systems. And we're throwing it all away because on top of all of that tech, we're just holding centralized stablecoins. And this is not sufficient. If we want to eventually arrive at a truly decentralized economy, one that's better than what we had before, we need to move past this. We cannot accept this as good enough. And so, you see the second category here, which is decentralized. And at first glance, it sounds like the problem has been solved. But we can see from the market that it definitely has not been, because these bottom tokens cannot scale to the size necessary. Of this 220 billion, the vast majority is in these centralized systems, which scale very well, and only a small portion is in these decentralized alternatives. And the reason is because these have to be over-collateralized, which means that you're basically putting money in a contract, you're locking away, and that money is not doing anything for you or generating any value. It's very, very inefficient. And so, coming from, in the last slide, this was the state of the game today, and this is also the state of the game 5 years ago. Almost nothing has changed in this time. But 5 years ago, people wanted to change it. People had belief that we could do better, that we could create a scalable, decentralized stablecoin, and people were working towards that. But now, 5 years later, it never came to fruition, and we've given up. People don't work on it, and it's extremely taboo to work on it. And so how did we go from this place of really believing in this mission to being afraid, being terrified? And the way that we did this is through a traumatic history. All of the tokens you see up here are previous attempts at creating an algorithmic stablecoin. And this is definitely not an inclusive list. There are many, many more. But basically, every attempt has failed in some capacity. Unfortunately, the ones on the left here are the reserve-based systems are the more household names. These are the ones that people are really familiar with and really traumatized by. Primarily Terra Luna and UST, which was a disaster. It was a complete disaster. We saw, this system grow way too fast, up to 18 billion, and then within, 2 to 4 weeks, go down to almost zero. And the entire industry just took that $18 billion hit with, retail users really bearing the brunt of that. And this token primarily spawned the FUD around algorithmic stablecoins. But all of the, a lot of these other attempts also failed. And so when I say algorithmic stablecoins, this is what people think of. They think of Terra Luna and this reserve-based strategy, and they saw that it didn't work, and they assume that every other attempt will be the same and will fail the same way. But I think this is the real failure here, because this is a very limited way of thinking about the way that we can solve this problem. Truly, there's so many different tools that we have at our disposal to create a better system. So to really quickly break down these two types of systems, without getting too technical, the reserves-based, which you see on the left, they basically hold a pile of assets outside of the stable coin, and when the price of the coin goes down, they attempt to buy back the coin indirectly and push the price back up. The issue here is that when the reserves run out, there's no lender of last resort. Things spiral, confidence goes down, there's a bank run, and the token goes to zero, either very quickly or gradually. And we've seen this play out many times. And I don't think that there's really any future where this reserves-based stablecoin succeeds on a long time horizon. On the right, you have credit-based stablecoins. And a credit-based token, a credit-based currency is really not anything novel. This is the same type of mechanism used to maintain all current modern currencies, like the US dollar. It uses a system where users can give a loan to the protocol and exchange the belief that in the future they will be paid back. And this is how they maintain price. And the protocols you see here are more of a lineage rather than a random selection. So each of these protocols, starting in 2021, made an attempt at creating a credit-based stablecoin. And each of the protocols learned from the ones that came before it and did slightly better. And I think this is really where we need to continue our efforts, because each attempt can be slightly better than the last attempt. And we can, there's a lot of data to say that something like this might work at scale, and it might solve the problem between centralized tokens and unscalable tokens. Right, so I think that so I would really want to encourage people to distinguish these two types of systems from each other, and open your minds to the fact that maybe a credit-based stablecoin does have potential to work. And so the question that I ask myself pretty regularly when I'm working on Pinto, and the question that I would encourage a lot of people to ask themselves when they're feeling upset by this term, algorithmic stablecoin, is should we give up? Have we suffered enough? Are we so hopeless about the future of this system that we need to just go home, lick our wounds, and accept that the economy will be centralized forever? And for me, it's a resounding no. Like, we can't give up at this point. We've come this far in creating a decentralized economy, and I think we can go a little bit further. And I understand that there's been a lot of pain in the past, and there's a lot of risk in the future, but I refuse to believe that this is the final threshold, the one single point where we cannot cross over from a traditional financial system into a new, better, decentralized financial system. And so I will continue to work on this and continue to push this needle forward. And I really encourage everybody to consider that maybe there is a way to create a healthy, decentralized, and scalable stablecoin. And that's all I want to say. So I'll be around all day if anybody wants to talk more.
Thank you. Next stop, let's welcome Ayush from Nethermind, talking about what the F is Surge, the ultra-based rollup. Welcome, sir. Some technical issues, as always. It's okay. Good time for me to also grab a coffee, and you guys feel free to as well. Oh, there we go. No time. We should start. Let's go!
Hello, hi everyone. So my name is Ayush Giri. I work as a senior developer at Nethermind, and today I'm here to talk about what we are building when it comes to based rollups. Okay. So the question is, what is Surge? So Surge is basically a fully decentralized based rollup template, which has stage 2 security from day one, and it operates with a tokenless design using ETH, and it achieves gigagas throughput through Nethermind client, and it employs a 2x3 multi-prover security model, all while maintaining complete alignment with Ethereum's core values of decentralization, security, and censorship resistant. So I feel these were a lot of words. So let me try to explain each one of them one by one. And okay, so when we look at Ethereum's scaling journey, we face that what's often called a scaling trilemma, in which we have to compensate one of the three factors and select only two, which is between decentralization, security, and scalability. So most layer 2 solutions make the same compromise, and they introduce centralization to achieve scalability. So this is what they called as a centralized sequencer, and which is basically a single entity which decides how to order transactions. And this creates a fundamental tension between Ethereum's core values and the scalability issues that we are trying to solve. So let's first understand how rollups work, and if just by raise of hands, if I can see like how many people know how rollups work in the background. So, okay, so maybe we can explain how rollups work in the first place. So let's begin by understanding why rollups matter and where the current solution falls short. So Ethereum's base layer can process only a certain amount of transactions right now due to its decentralized nature. So rollups emerge as a solution and an alternative to solve this scalability issue by batching transactions off-chain and posting compressed proofs back to Ethereum. This approach has been successful at increasing the throughput, but comes with a critical design choice, which is centralization again. So the basic concept is simple. Instead of executing every transaction on Ethereum, we do that off-chain and post the proofs on-chain. And this significantly increases the number of transactions that we can process, but uh, it does not inherit the decentralized nature because there is a centralized feature involved, which as I said, is a centralized sequencer. So most rollups today use a centralized sequencer model. A sequencer is essentially a single entity responsible for collecting user transactions, determining transaction order, and producing blocks to submit it on Ethereum. Which brings us to problems which these sequencers bring with them. First, it introduces a single point of failure. If the sequencer goes down, the whole L2 becomes broken. Second, it creates a censorship vector, which means the sequencer can choose which transactions to be included in the L2 block and which transactions to be not included. Third, it concentrates power in the hands of the people who are controlling the centralized sequencer. And these guys can take the benefit of the MEV strategies that we know right now happens on the layer 1 as well. So it relies on the reputation system of the L2 as well, which means many L2s claim that right now we have a centralized sequencer, but in future we would decentralize it. And this is the promise that they give us. But we have seen that it has not happened yet with any of them. And this is where the concept of based rollups come into picture. So it's not just a theory because many people have already established this. For example, like Tycho, Puffer, and some of them. So a based rollup takes fundamentally different approach by eliminating the use of a centralized sequencer, which means that Ethereum's own validators are the people who are responsible for ordering the transactions and block building for the transaction ordering. So the term based refers to based on Ethereum, which leverages Ethereum's existing infrastructure for critical function of transaction ordering rather than introducing a separate layer of sequencing. In this model, user technically submits transaction directly to Ethereum's mempool. Ethereum's decentralized network of validators and builders handle the inclusion of these transactions, and the rollup inherits Ethereum's security and censorship resistant property, which for other rollups is only the security feature, not the censorship resistance part. So it's fundamentally a different approach. Instead of creating a separate sequencing rule or layer, we are using the infrastructure which is already present in the system and using the Ethereum validators. And this is closely tied to the proposer builder system, which is a concept in Ethereum's roadmap that aims to keep block building open and permissionless. So think of it as a Ethereum native sequencing. We are leveraging the existing infrastructure instead of creating a whole separate sequencing layer. So the benefits of this approach are quite obvious by now, which means there's no centralized entity that can censor or reorder transactions. So if your transaction goes into Ethereum, it will be processed by the rollup as well. Second, the security is identical to Ethereum itself. Based rollups inherit Ethereum's decentralization nature. Third, there is no need for an additional infrastructure or governance mechanism for transactions ordering, and you are using what already exists. So there is no separate tooling, there is no separate tools that are required. So base rollups are fundamentally aligned with Ethereum's values from day one, which means they are as decentralized as Ethereum itself because they leverage the same security that Ethereum has. So this approach represents a return to core principles. So decentralization isn't in the future roadmap, but it's based inside Ethereum from the beginning. And this is where we come to Surge. So Surge is Nethermind's implementation of a based rollup template. So it is not basically another rollup, but it is a rollup template that anybody can use to roll up a L2, which can be used by institutions or any other player who wishes to have an based L2. So it is just a research and experimentation showcase by us, and it is designed to showcase what happens when you maximize both performance and decentralization without any compromises. So we built Search to demonstrate that trade-offs other rollups make are not technically necessary, that we can build systems and scale them without sacrificing Ethereum's core principles. And the 5 key differentiating factors for Surge are: it has a fully based architecture, it has stage 2 security from launch, and I'll be explaining what a stage 2 security means. It has a tokenless design, it has gigagas performance because of the Nethermind execution client, and it has a multi-prover security model, which brings us to a 45-day window. So let's deep dive into what stage 2 security means. So basically by L2 beat, there's a definition given of what a stage 2 rollup should look like, which means it should have no training wheels. And this is the final stage where the rollup becomes fully managed by smart contracts instead of having any centralized entity or any fallback mechanisms. So a 45-day exit window for any upgrades would be required, giving users ample of time to withdraw their funds if they disagree with any changes of the L2. And no emergency powers, which means there's no ability for anyone to force changes without going through the time lock. And limited governance, which means the multisig can only queue upgrades, not execute them immediately. So this means that from day one, Surge provides the strongest possible security that is possible when it comes to building a based rollup. And we are not asking users to trust us, but we are building a system that doesn't require trust itself. And this is in smart contracts it is in contrast to other rollups, which often start with extensive admin powers, and they say that they would be removing these training wheels as they progress in the journey. And so the next term is a tokenless design, which means Surge uses Ethereum exclusively for gas fees and protocol bonds. And protocol bonds come in the consensus part of the Surge rollup. And so basically, and these rollups which will be deployed using this template would not have a new token, which means they use ETH exclusively. And this isn't just a philosophical choice. It eliminates misaligned incentives that often come with token economics, which other L2s do usually. And this is the best use case that any institutional level player can have, because usually these institutional level players don't have any tokenomic incentives to take benefit from. So basically it would be using ETH as a gas and for protocol bonds. So the next part is gigagas performance. So what does it mean? It means that it is powered by the Nethermind execution client, which we have in the L2 level. So Surge achieves extraordinary throughput, and we are talking about processing 1 gigagas per second, which is actually proven on base mainnet by the Nethermind execution client. So this isn't just a theoretical claim, it's been demonstrated, and in the version 130.0 release of Nethermind execution client. So the technical improvements that make this thing possible are faster memory pruning that runs in parallel, optimized storage processing, and special speed enhancement for cryptographic operations using advanced CPU instructions. So these are some jargon words. I mean, I don't want to bore you by repeating those things. So the next part is a multi-prover security model, which means that Surge relies on two of these three provers which are involved, which means there is a 2x3 consensus model agreement from multiple independent proving systems. One is an SGX based TE, other is SP1, and the last one is Risk Zero's RICO. So this removes single proof point of failure for the system and uses different security assumptions and common vulnerabilities. So the system remains secure even if one prover is compromised. I mean, it depends on the L2, which is deploying this rollup template. They can have more than 3 provers. It's a choice that they have to take depending on the trade-offs they want to do. So together with these innovations, we create a rollup that's both high performant and highly secure without compromising on Ethereum's core values. And I repeat these things again and again, but we have this mission to not compromise on the Ethereum core values for whatever we build at Nethermind. So unlike traditional rollups that chase mass adoption, Surge is not meant for attracting any users, to be honest. Surge is intentionally designed for a specific technical audience of researchers and builders. And we are not focused on onboarding any users or million people onto it. We are focused on showcasing how the state of rollup technology should advance in the future. So this is a research-focused approach by us, which allows us to make design choices rapidly and prioritize technical efficiencies rather than onboarding millions of people. So we don't need to make any compromise to attract users. We can build the ideal system from first principles. And it's already pretty perfect right now, but we still feel that there are some optimizations that we can do. And so Surge serves two key constituencies, which first one is builders and the second one is researchers. So the builders part includes block builders and MEV searchers exploring cross-layer opportunities. For them, Surge offers a predictable environment for transaction inclusion and direct integration with Ethereum's block building process and new MEV strategies or opportunities across layers. And Surge also comes with a cross-layer composability feature, which I'll be explaining later in the slides. So the second part is researchers, where technical teams working on rollup optimizations can work and collaborate with us in terms of protocol design. For them, Surge provides a clean implementation of what a base rollup should look like when it aligns to all Ethereum core values. And this is an open source code that can be studied and modified on GitHub if you would like to see that. So let's talk about another thing which comes along with Surge, which are called Surge power-ups, which are basically plugins for your based rollup, which you deploy using this template. When I say plugins, I want to say that these are some of the features that not every based rollup would require, or the deployers of the L2 would not want. For example, pre-confirmation and efficient proving and block building and cross-layer composability, because it depends on the use case of the base rollup that is trying to be deployed. So the first power-up is pre-confirmations. I can go on to explain what pre-confirmations are, but it would require a separate 30-minute workshop. So think of it in this way, that your transactions are being included on Ethereum L1, as we said, in base rollups. So you would feel that all these transactions would take the same block time, which is 12 seconds, that Ethereum takes, because the Ethereum validators are the one who are including these transactions. So pre-confirmations can be thought of like a bond which someone gives, saying that, okay, your transaction is going to be included on L1, and this is the guarantee that I am giving you. So you get the transaction confirmation within like 200 milliseconds or like 100 milliseconds or maybe even less than that. So and then the second power up is actually optimized proving. So this consists of advanced ZK proving systems that improve efficiency and reduce costs, which will be tailored specifically to the needs of that particular L2. And ZK proofs require typically too much effort when it comes to building the circuits. So by optimizing this process, we significantly improve the performance of the L2 while maintaining security. The third power-up is advanced block building. This provides tools for builders to optimize value extraction and transaction ordering across layers. Search-based architecture creates unique opportunities for block builders to coordinate across L1 and L2, creating more efficient markets and reducing negative MEV effects, which actually all of us don't like. And the final power up is seamless layer composability, which in simple words means that we are increasing the efforts in reducing the fragmentation across L1 and L2s. This provides a framework for us to have cross roll-up communication, allowing participants to work seamlessly through all the templates that are being deployed using this, all the roll-ups that are being deployed using this template. So in simple words, I would say that all the based roll-ups that are deployed using this template can communicate with each other without any bridges or any messaging protocol between them. So Surge isn't actually a product that we want to build and attract users with it, but it's just a, again, I'm repeating this, but it's just a technical showcase of how good team of researchers and engineers we have at Nethermind. And it is one of the truly decentralized, high-performant scaling solutions. So we invite you to join us in this journey. So there are many ways in which you can get involved. So you can explore the code on GitHub. You can visit the website using this QR code, which is search.wtf. And you can participate in discussions about the future of based rollups, because that is what we feel the future would look like. And we can continue to push the boundaries of what's possible. So I think like I'm a little ahead of time. So thank you for your time today. And I believe Surge represents an important step forward in realizing the actual principle that Ethereum has when it comes to future roadmap. And I'm excited to see how people react to this technical showcase by Nethermind. And and this is what we feel the next generation of blockchain would look like. So thank you.
I think we have a little bit of time for questions. Is there any questions? Maybe one? Yes. Right.
Hi, may I understand like search, what language is it based on? And if it's based on Go, then which stack did you actually pull up from? Yeah.
So it is actually based on Go, and I would like to point this out that this is something which we built in partnership with Taiko, which means that we have modified the Taiko stack to be relevant to the changes that we require. For example, the tokenless design, which I said, the multi-prover security model, and all the other features which I mentioned are something which we modified from the Taiko stack. So basically whatever applies to the Taiko stack applies to us. So this rollup template would deploy the L2, which is EVM compatible. Solidity would be used as a language for programming any smart contracts on it. And yeah, I mean, like, are you asking about what is the actual tech stack behind it, like in which language? So it is in Go, and you can contribute to the code on GitHub if you would like to. So we are actually looking for people who are good at researching and engineering, and yeah.
All right. I actually do have a question.
Okay.
So, you know, like recently, you mentioned like one of the benefits of like you know, this base rollup is that it doesn't require bridging between all these base rollups, right? And recently, the super optimistic kind of like ecosystem are also OP Stack is essentially also talking about the same thing. I was wondering whether, because obviously that's another stack, right? And is there a pathway that is very clear for you guys to see like whether these OP or other rollups essentially that are adopting other architectures at this moment to be able to upgrade into base rollups in a simple manner? Because ideally if that is kind of like present and it's just a matter of decision, then it's kind of like easier to gather all the liquidity. Hence the question. Thank you.
Okay, so I feel it would not be possible for these OP stack rollups to shift to being a based rollup because from an architectural point of view, these are two separate things and they still need a centralized sequencer when it comes to OP stack. The only thing which OP stack has similar to this is the cross-chain composability feature which we talk about. But in them, it is the cross-chain composability component is coming because all of them are built on the same stack. But in this case, all of these transactions are going through Ethereum validators, and that is the reason it is having this cross composability feature, which means that technically we did not do anything. We are using the infrastructure which is already there, and we don't want to create overburden for creating an L2. So to answer your question, I don't think it would be possible for the OP stack to convert to being a based rollup if they don't make changes on the architectural level.
Yeah, I agree on that one. I was mainly thinking whether it would be an easy change or not. Because if it's an easy change, then, or like some sort of like module for like, hey, you know, just give up on the sequencer, then, whoa, suddenly you are based and ultra based.
Maybe we can try creating a module for the sequencer part, but technically that is the part which is entirely different between these two systems. So it is again a architectural choice that these guys would have to take, that if they want to do this thing or not. Because right now the plugins which I was mentioning about, like pre-confirmations, are still something which is under research by many people in the ecosystem. So it is not something which they can adopt right away. Yeah.
Sounds good. We still have a little bit of time. Another question? One more? Nope? We good? All right, seems like we're good. Thank you, Ayush. Thank you. And next up, let's welcome Marek from Zello about May the Proof Be With You, fighting Sibyls with Self-Protocol. And in the meantime, Zello, is it this week, last week, just converted to L2 as well?
Last week, yeah.
Last week, converted to L2. Welcome home! Woo!
Thank you. It's good to be home. So yeah, today I'm going to be talking about something a little different than that. Looks like we have a technical issue. 1 second.
All good?
Perfect. So today we're going to be talking about something slightly different. Self-protocol. I'm really, really excited to share this with you today. Amazing. Looks like we're all done. Let me just hide the little thing at the bottom. Ooh. Can I hide it? You know what? I'll just leave it. Self-protocol is a new protocol that we just launched a few weeks ago at ETH Denver. And so you're seeing this hot off the press. So it's really, really exciting. And if you like this talk, you can follow me at Marek_ on Twitter. My DMs are open, happy to answer any questions. And you can learn more at self.xyz and also at self-protocol on Twitter. And so the talk today is, may the proof be with you, fighting Sibyls with self-protocol. And, I couldn't help myself. I had to get in on this Ghibli craze and create some AI art for you. But I think the metaphor is actually quite fitting. If you think about Sybil attacks, and if you think about the clone army in Star Wars, clone army is made up of clones. And so these are all Sibyls. And so you can think of yourself as kind of being one of these Jedi Knights that's using the power of self-protocol to help protect you against these Sybil attacks. But before we talk about how exactly you're going to do this, I wanted to introduce a little game that we're going to play during this talk. And the game is Guess the Country. So throughout my slides, it's the afternoon, it's after lunch. I want to wake you guys up a little bit. And the way I want to do that is I've sprinkled a few country shapes throughout these talks. And so if you see a country that you recognize, just yell out the name. We're going to try to make this competitive. We're going to maybe do like the left side of here and the right side of here, try to make you guys compete against each other. If you don't recognize a country name, just guess. The idea here is to make this fun, make this interactive. And so just to start you guys off with an easy country. Australia, okay, the left side's already winning, guys. What are you doing on the right? And I should add, this isn't arbitrary. Each of these countries is supported by self-protocol. Taiwan, of course, is also supported, but that would have been too easy for you guys, so it's not here on the slides. Okay, one more, a little warm-up. France, okay, 1-1. Next one. Canada, okay, right side is winning now. You guys on the left have to step it up. Okay, so now that you guys have an idea of what the game's like, again, look for country shapes. They're gonna be like sprinkled on top of my slides. And if you see a country you recognize, just yell it out. Okay, so I wanted to start by, talking about some of the biggest problems in crypto. What do you guys think? What are some of the big kind of unsolved problems that are plaguing us today? Any guesses? Nothing? Are we done? Too many problems. Okay, what are some of them? %. Sybils, these are real problems. Any other guesses? No problems? Liquidity fragmentation, it's a good one. Anything else? Privacy, UX, yes. Okay, finally, you guys are warming up. Lots and lots of problems. Any last remaining problems? Really good. A lot of the finance is collateral based. A lot of lending markets require you to deposit collateral. Possibly also related to the fact that we're using capital as a way to solve Sybil problems. Okay, so I agree with you. Yes, are you sibling is a big problem that we continue to struggle with answering. It's a little ironic because proof of work, in theory, look to solve this, but it requires a lot of electricity. Proof of stake solves this as well, but it requires a lot of capital, like those collateral-based lending markets. And then WorldCoin has solved this using, these orbs, but you have to be physically close to one of these orbs, and you have to be willing to, give up the privacy of how your iris looks. And so arguably, that hasn't solved the problem either. And so, are you sibling is kind of this open question that we've really struggled with as an ecosystem to solve completely. Anybody want to guess that country? Spain. Yes, I think that was on the left. So we're 2-2. So it's still neck and neck. Another problem, which I don't think anybody mentioned just now, is are you a bad actor, right? We had a rude reminder of this a few weeks ago with the Bybit hack. This is something that we really struggle with as an industry, and it's very, very difficult in a decentralized way to offer mechanisms to try to filter out bad actors. And so I would argue that this is a big, big unsolved problem today. And then finally, who would have thought Singapore is right? 3-2 to the left side. Let's keep going. Are you human? Who would have thought we'd be having to worry about this question in today's day and age? But yet, with AI agents today, this is increasingly becoming a problem. I don't know, has anyone here read a tweet and wondered, did a human write that, or was it just an AI agent? Anybody? Okay, at least one person's on Twitter. There's a lot of crap on Twitter lately, it's crazy. And so it'd be quite useful to be able to know if these are bots creating this content or not. And arguably, it'd actually be useful for these AI agents themselves to know whether or not they are interacting with humans or not. And certainly over time, once AI agents are doing all the work and we're all living off of a UBI, certainly it'd be useful at that point for us to be able to know who's a human and who isn't, so that only humans get those UBIs. Okay, so Self protocol is really a new protocol that's designed to help, among other things, to answer these exact questions. And it's a new decentralized, zero knowledge ZK Snark-based protocol that we're really excited to be sharing with you today. Again, we launched it just a few weeks ago at ETH Denver, and it's the result of two teams coming together. The Open Passport team, which is a team that's been funded primarily by Ethereum Foundation grants for the last year and a bit, and Self Labs, which is a company that's spun out of the Cella Foundation. And we've come together to bring you this new protocol that we're just really, really excited to be sharing with you, which again is designed to help address some of those big open questions that we're facing together as an industry. And the way it works is by piggybacking on what I like to think is the biggest meat space attestation of your humanhood, probably the best such attestation that you can receive, and that of course is a physical passport. Who here has a physical passport? Okay, hopefully everyone. And one of the really nice things about passports is that they're relatively difficult to get. It's very difficult, if not impossible, to get two of them, certainly from one issuing country. Because you need them for travel, you generally keep them quite secure, and so they're generally harder to steal. And then these new biometric passports, and I say new, but really these things have been around for 20 years, these passports with that little logo, the little rectangle with a circle in the middle, those passports are called biometric passports, and they have a NFC chip inside them that actually stores your biometric data in a way that can be machine readable, certainly by the machines at the port of entries, but also by your mobile phones. And so that makes these identities really quite conducive to a new online identity system that we're going to be talking about today. Turkey is right, 4-2. You guys had like 1 minute to guess Turkey. Lots of time, come on. We gotta get some points on the right side over here. Okay, and so the way that these biometric passports work is they have your biometric data. This is a data that exists on your front page of your passport, stored digitally in a microchip in your passport, and it's signed by a certificate authority chain. And what that means is it's signed by multiple, effectively a chain of signatures that go all the way up to this country signing certificate authority, right? So the data itself is signed by this document signing certificate, and then that certificate can sign about 100,000 passports before it's retired. And each such certificate is then signed by a country signing certificate authority. And typically these country signing certificate authorities are long-lived. And so if you have all of these public keys to these certificate authorities, there's a little bit under 200 countries. Each country maintains roughly 2 of these at any point in time, so roughly 400 certificates. If you know these 400 certificates, you can validate the authenticity cryptographically of any passport in the world. And that's really powerful. And so, these passports, they've been introduced now 20 years ago, and countries have rolled these out in order to make it really hard to forge these passports, right? It's no longer good enough for you to, print, the perfect, passport copy on the perfect paper with the perfect photo. If you don't have access to one of these keys, and, obviously these are closely guarded by these countries, you can't effectively forge a biometric passport. And so that's pretty nice. But what's even cooler is we can actually verify this just using math, just using cryptography. And we can do that without a counterparty. Right, so who here likes sharing their passport data with third parties when you're doing KYC? Third parties that may get hacked, may leak your data, may sell your data. Who loves sharing that data with these third parties? Anybody? Nobody, right? So instead, what if we could simply prove facts about yourself or even prove that you have a valid passport, let's just start there, with just cryptography, where you verify that certificate authority chain on chain. So in a smart contract, you verify those signatures on a chain. Who would prefer that? Yeah, a few of you, right? But it's a trick question, because if we did that, we would be revealing all of your passport data to everyone in the world who can have, who has access to that chain. And so instead, what if we could verify that certificate authority chain in zero knowledge, so that you're proving it with just math, with no counterparty, but without revealing your data to anyone? Who would like that? Well, that's in effect self. Self allows you to register, where you're effectively, again, proving that certificate authority chain in zero knowledge, on chain, without a counterparty. And once you've done that, you can then selectively disclose specific facts about yourself in zero knowledge, right? So today, if you need to prove that you're from a certain country or that you're over a certain age, you have to share all of your passport information with some counterparty that then goes and says, okay, yes, that looks correct. Yes, I can do the math. You're over 18 or over 21. But to do that, you have to share all of your information with these counterparties. But now, with ZK Snark zero knowledge technology, we can actually prove these statements about yourself without revealing additional information about yourself. Pardon? Yes, Czechia, technically. But which side are you on again? Okay, so now we're at 3-4. We're getting close to even. Let's keep going. That was a good guess. This is probably the hardest country on the map so far. So yeah, so say that you want to prove that you're over a certain age, right? Now, with self, you don't have to actually reveal your age to prove that you're over, say, 18. Say that you want to prove that you're not from a set of countries, you can do that without revealing what country you are from. And better yet, say that you want to prove that you're not on the OFAC list, you can actually do that now with self without revealing pretty much anything else about yourself. And so it's pretty exciting. And best of all, you can do all of that and then associate these proofs with a particular address. So say that you want to interact with some dApp that maybe depends on one of these proofs. Maybe it's a trusted DEX that only allows folks who are not OFAC sanctioned to participate in the DEX. You can verify that you're not on the OFAC list, associate that proof with an address, and from that point on, you can have that address be basically allow listed by that DEX, and then that effectively unlocks access to that DEX. So you can make this proof once, and then from then on be able to use that DEX using your address. And if you want to use another address, maybe for a different application or even the same one, you can construct another proof where you can again prove that you're not on the OFAC list, associate with the address, and those two addresses won't be linkable to each other. And so each of these proofs, again, are done fully in zero knowledge in a way that doesn't allow you to then link them to your identity or even to other proofs that you've generated. Okay, so you might be wondering, okay, you have a rough sense of what this is. Okay, we're proving passport data in zero knowledge, selectively disclosing information to third-party dApps, but what does this whole experience look like? We have a little recording here of the onboarding flow. So that's the first screen when you install the app. First step is to scan the passport. Turns out the data on the NFC chip is actually encrypted, and you need to scan the front page of your passport to be able to decrypt that data. This is a nice security feature so that someone can't bump into you and steal your passport data. Once you've scanned the first page of the passport, you can then tap the passport with your phone to read that NFC data. Once you've read that NFC data, we can generate that proof. And then you're off to the races. You're on the home screen. So let's see that one more time. That was pretty fast the first time. So we get started. We quickly scan the front page of your passport. This allows us to then decrypt the data on the NFC chip. You read the NFC data by getting your phone onto the NFC chip on your passport. The hardest part is actually finding the NFC chip on your passport. And then you generate the snark proof, and then you're done. You've onboarded. And so once you've onboarded, and I should add that you can only do this once. And so say you wanted to, use your same passport, use a different phone, try to register twice, again, try to create a Sybil account, that ZK, that snark proof effectively wouldn't allow you to do that. And so we basically, at registration, prevent these Sybil accounts. And then once you've registered, now you can start interacting with dApps that are interested in learning something about yourself. And the way we do that is through QR codes. So each dApp, we have this nice web SDK. Each dApp can generate a QR code. That QR code encodes what information the dApp would like you to disclose. That information is shown to you on the application, and if you agree to disclose it, you can hold down the button, generate a new snark proof that effectively proves that disclosure. So this could be as little as, I'm someone who owns a passport without revealing, who even issued that passport, all the way down to disclosing everything that's on your passport page if you would like to disclose that. Poland is right. Okay, so I think we're at 5-3. Okay, this is the final inning, guys. Everyone's gonna pay a lot of attention now. Okay, let's see this one more time, because once again, that was pretty fast. So the dApp generates a QR code. We scan the QR code with the app. We look through what the dApp is requesting. If you agree to reveal that, you hold to verify. We generate a new snark proof. If that dApp is a Web 2 dApp, the proof is sent to that dApp through a webhook. If it's a Web 3 dApp, then we write the proof directly onto chain, where it can be verified on chain. And so this self-supports both Web 2 and Web 3 use cases. And again, you can send those proofs either on chain or off chain, depending on your need. Okay, so how does all of this work? Well, it starts with a passport, of course, the biometric passport with an NFC chip. We have our mobile application that reads the NFC data. One thing that we did that we think is very important is we generate a secret for every passport, and we then back it up in the key store, in the iCloud key store, and then also in a secure part of Google Drive if you're using an Android. The secret is needed effectively to keep your information private from countries that have access to your passport data. So obviously your issuing country has your passport data, but also any country that you travel to typically has your passport data as well and can read the NFC chip on your passport when you're going through customs and immigration. And so to protect you from those countries seeing which dApps you're interacting with, we generate this secret, and to prevent you from losing that secret, we back it up for you automatically. If you don't trust iCloud and Google Drive, then you can also write down the secret manually on a piece of paper. With that secret, we can then generate these snark proofs. And unfortunately, the proving systems of today aren't really efficient enough to run on your mobile device. And so rather than waiting for these proving systems to get faster, we decided to accelerate the proving by using a trusted execution environment. So these are these secure enclaves that are running in the cloud. And the nice thing about these things is they're tamper-proof. They provide attestations that they are running very specific code. Those attestations is then are sent to your mobile device. And only once your mobile device receives that attestation will it send your passport data in an encrypted channel to this TEE. And that way you can be certain that the TEE is not running any code that will send that passport data to some database or leak it in some way. You're always guaranteed that that passport data is going to be used only for generating that snark proof and then deleted. And so the TEE can generate those snark proofs relatively quickly. These are big, beefy machines. And then for cases where you need these proofs on chain, we write them, to the Celo chain. And because we have built-in Sybil resistance, we can actually pay for gas for you. And so the user doesn't actually need to connect the wallet to the Self app. All of the gas is taken for you automatically. And again, that's something that we can do because we have built-in Sybil resistance, which is pretty neat. So if you're a developer, if any of this sounds interesting, we're really excited for you to test out Self. Again, it just launched, and so we're very eager to get your feedback and for you to start playing around with it. So if you have any use cases where you might be interested in defending against Sybil attacks, maybe you're also interested in preventing bad actors from using your protocol, or you're in the AI space and you're struggling with knowing whether or not a human is interacting with you or an AI agent, and you'd like a way for people to verify that they are in fact not AI agents. All of these use cases, recovering a multi-sig wallet is another use case that's commonly cited that's I think pretty exciting. All the way down to these fun little kind of more frivolous ideas, but might also be fun to play around with. If you're into meme coins, you could generate a meme coin that requires you to verify something about yourself using Self. So you could do like a Bob coin where only Bobs can participate in that meme coin. So anything you can think of, you can play around with. If you want some very concrete ideas, that's right. Chile is right. This one. And then another point as well, which I think, wait a minute, this was on this side. We're tied. That's amazing. Yeah, so if you're interested in building an airdrop, or launching your own airdrop, or launching an airdrop service that offers Sybil resistance, you can use Self for that. If you're interested in creating a marketplace for AI agents and humans to trade work, and you need agents to be able to confirm that they're actually paying real humans, you could do that with Self. If you want to do an initial DEX offering where you can give individuals some sort of discount, that would be difficult before, but now you can do it. We talked a lot about these OFAC filtered DEXs, OFAC filtered lending markets. And then on the meme coin front, it's pretty cool. You can verify that it's someone's birthday. So you could do a birthday coin where you give out coins to people on their birthdays. Again, you can do a Bob coin where you give out coins only to people named Bob. Pretty much, anything that's on your passport kind of first page, you can use that information now to do fun things on-chain in a fully decentralized way without a counterparty. So yeah, that's everything. Thank you so much.
Right, we have some time for questions. Any questions? Yes, sir. Running over.
Thanks, interesting talk. Could a nation that's scanned your passport that you've gone through immigration impersonate you?
Yeah, it's a great question. So it depends a little bit on your passport. So newer passports have this thing called active authentication, which effectively prevents people from impersonating you if they've just read your passport information. So newer passports have the technology to effectively prevent that. Not every country, unfortunately, uses this technology. And so the answer is, certainly for those passports, yes, unless you register first. So as soon as you've registered, because we derive that extra secret for you, at that point on, no one can impersonate you, no one can register again. And so if you're concerned about that, and I suspect, most countries are not going to be thinking about this right now, but if you are concerned about it, certainly I would definitely encourage everyone to register ASAP, and that's the best way to protect against that.
there. Oh, this is like a maze. Thank you, sir.
Yeah, I guess I have two questions. One is what happens if you lose your seed phrase? Is it possible to still access? And the second question is, I forget the second question now, but yeah, just the seed phrase. What happens?
Yes. So if you lose your seed phrase, you won't be able to, and you've uninstalled the app. If you haven't uninstalled the app, then you can just read the seed phrase in the app itself. But if you've uninstalled the app or lost your phone and lost the seed phrase, then you will need to get a new passport to be able to participate, which luckily you can do. It's a lot easier than recovering a wallet after you've lost the seed phrase from that wallet.
So when you're generating the proof, there's a business logic associated with it, typically called the proof function. So how do you specify or code up the proof function for the proof generation?
How do we specify it?
Yeah, well, how do you code it or specify it? For example, I want to specify, I like to compare this string and that string, and like very specific business logic, right? Given the documents, for example.
So if you're asking, how we've written these proofs, we've done it all in Circom. It's all open source, so you can take a look at the code. And then we have a detailed spec as well in docs.self.xyz.
Okay.
All right. Oh, you have a very engaging. I actually also have a question. I'll leave it for folks.
Does this work in every country on the planet, like in Africa?
So every country that issues biometric passports, we worked really, really hard to support basically every country that issues biometric passports. Now there's, unfortunately, there's no standard as to which hash functions and which signing functions countries are using for the certificate authority chain. And worse yet, they sometimes change these functions as you go up this chain. And so for every permutation that we've observed and that's been documented online, we've worked really hard to support. We're discovering every now and then that some country has issued some number of passports with some new permutation of these things that we weren't expecting, and so we're actively updating the protocol every time we encounter that. But we're feeling pretty good about the number of countries and passports we support. So I think if you have a biometric logo on your passport, then I would expect that we will be able to scan your passport.
You said that the passport data is encrypted before sent to the TEE. So you're doing zero-knowledge proofs on encrypted data. I was just curious if you know what mechanism you're using to perform that.
So it's encrypted when it goes to the TEE, but then it's decrypted by the TEE. So it's not being proven while it's encrypted. And if you trust the TEE, then you don't need to keep it encrypted. I think longer term proving mechanisms will get faster and faster. We'll be able to generate these proofs on phones, so we won't need the TEE. But for now, this was the only kind of practical way to get to market and give you the benefits of self. With, arguably the only small downside that you have to, trust Intel to not have an exploit there. But again, your passport data is not stored on those TEs for very, very long. And so I think that should give people a lot of comfort.
Is the code on the TE open source in the app code?
Yes.
So then we don't have to trust, we just have to verify.
That's right.
Which is the beautiful thing here. I actually have a last question and maybe we can close it off. Oh, is there like a hand there? Right, I'm gonna give it to him. And I'm crying. Hopefully you ask my question, sir.
I finally remembered the question, which is that is it possible to unscramble, like supposing a wallet which has registered has now done something shady, is it now possible to unscramble and get the name of the person, or is that like since they only had to prove that they were from this country, we can't find out who this person was?
That is correct, yes. You can't reverse engineer the proof. You could maybe encourage the owner, yeah. If you're saying if there's a bad actor that somehow was able to generate some proof and now is doing something shady that's observable on chain, can we use this to figure out who that bad actor is? And the answer is probably not. It really depends what was disclosed when the user initially created that proof.
Sorry, one sec.
Could you then kind of like deny list that proof and be like in the future, or like put it on a specific list of being like that has been in bad actor?
Yeah, so I think the difficulty is associating that address with this identity of that user. I think because of the way that the system is designed, again, for everyone's privacy, it's not linkable. And so we can't go backwards either.
All right. Selfishly, I was still gonna ask the last question. So I guess like the Sybil here, let's say if I want to Sybil, the effort that I need to go through is basically to have a new phone, have a new passport, and then can I register that again, or is that not possible?
Have a new phone, have a new passport, probably also have a new Google and Apple account.
Which is easy to get, actually, right?
Yeah, if you have all those, then yes, you can create another account.
Got
But you might be able to do that 1 or 2 times if you if you're lucky enough to have a passport from multiple countries. But beyond that, you're probably not going to be able to do it 100 times.
Yeah, like certainly like increases a lot of the effort for the Sybil. Like I cannot keep losing my passport for 100 times without raising suspicions.
Oh, even if you lose your passport, countries typically create these revocation lists. And so it's your lost passports, depending on your issuing country, whether or not they're maintaining these lists, you can actually verify in zero knowledge. In addition to verifying the certificate authority chain, you can also verify that you don't exist in one of these revocation lists. So there are ways to mitigate kind of the lost passport attack that you're referring to. I think realistically, it's only going to be people with multiple passports from multiple issuing countries that are actually valid that would be able to generate multiple accounts.
Awesome. Thank you so much for the fun presentation. And also I think it's like really important like to finally link the real world stuff and then onto the blockchain. And we can start adding some reputation, credit base, etc. All those things are built on top of this. And again, welcome home to Ethereum. And thank you, Marek.
Thank you.
All right, next off, we have Jeff from Portus talking about how did Portus reach 100 million in 365 days. Now I want to note, Portus is the sponsor of our happy hour. So, like the happy alcohol that we all consumed yesterday and hopefully later as well. It is sponsored by them, which is awesome. Awesome team. They're mainly focused on MEV and stuff. And now I will hand the mic to Sir Jeff.
Okay, thank you. So, hi everyone. I'm Jeff from the Portus team. And I can't remember when it's my last time speaking English on a stage, but let's give it a try. But because people are leaving, so I'll just speak slowly. So I don't know how many of you are coming for the 100 million, but let me clarify this at the beginning. So the 100 million we reached last year is RPC codes, not the income we made last year. And why Portus reached so many RPC codes last year? What kind of service Portus is providing? So Portus is top 3 of 23 solvers on the CloudSwap platform, and we settled 1.3 million USD on the mainnet in the last 30 days, which was 1.8 times of the average, and we filled 33,000 orders in the last 30 days, which was 2.2 times of the average. So basically, we're a solver who provide the best price for the users for them to do the swap. And And we also help people like Trump to swap from USDC to ENA, and we also help Vitalik to swap from Muden to ETH to do charity like for public goods he mentioned this morning. And what does 100 million RPC code mean? Like, because it's a very big number, right? So it means that porters will make RPC code like 385 times to the blockchain. But why does porters need to make so many RPC codes? Why? Because when we are trying to do a swap, there will be a lot of options for us to do the swap, right? We can swap the Ethereum to USDC directly, or we can swap the Ethereum to USDC with tokens in between, or we can split the amount of ETH to different pool and swap them to USDC. But these are some of the strategy we can do, but the goal of us is to provide the best price to the user. So why do we have to choose? All we have to do is get the price of all the options, and then we provide the best back to the user. So you can see that if I try to get the price of all these kind of possibilities from the blockchain, and then we will have to call the blockchain a lot of times. Not to mention that if we just say that if I want to try to swap ETH to USDC in a liquid pool, and then what I have to get the price for once, right? But what happens if I have 10 liquid pools I can swap? Then I have to get the price for 10 times, right? And now Portals has over 70 liquidity sources, and the liquidity sources here is not a pool. It means that maybe like it's curved, and there's a lot of pools in a liquidity source, which you can see that the more liquidity source we have, the more possible path we can find, and then the more RPC codes we have to make. And there was a time that Portals has found 1435 paths for a single swap. I don't know, did you remember your last swap by yourself, or maybe you do it by an aggregator or something? But I remember that if I do it by myself, I can only like find 3, 4, 5 paths, or maybe when I use an aggregator, maybe the aggregator just provide me that 3, 5 paths maybe. But Portals would find 1435 paths for you just for a single swap. Okay, but when we make this much RPC codes, what if our RPC endpoint cannot handle the traffic? So if the RPC endpoint cannot handle the traffic, there will be a lot of timeout error, right? Because they cannot respond to the data in time. And when that happens, when portals cannot get the price in time, we cannot return the best price to the user in time, which means that we have to give up to fill the order for the user, which means that all the efforts we made were in vain, okay? And so the first lesson we learned is how to choose an RPC endpoint. So the first thing you need to consider is the monthly quota, like how many RPC calls you have to make in a month. So, and you also have to consider if the market is cold or if the market is hot, because the RPC call numbers will be different. And then you will not want to have a lot of RPC call remain at the end of the month. So the first thing you have to consider is the quota. And then we found that the RPS is also pretty important too, because even though we have the enough monthly quota, if the RPS is not high enough, then the endpoint cannot handle the traffic as well. So you have to consider the RPS to be the right fit for your service. And then you have to consider the stability, because if you have the high enough RPS, you have enough quota, and if the endpoint is not stable enough, and let's say it happens like, it glitches like maybe once every 15 minutes or once every 30 minutes, then you will need to spend extra time to find out what happened in your system. Or maybe you have to write a complaint letter or create a ticket on the endpoint provider's web UI. Yeah, something like that. And then, even though you find the perfect RPC endpoint for you, you have to consider the cost, because if you cannot make up the cost, then the RPC is not the right fit for you. So here are the few things we learned from the RPC. Besides the RPC, yeah, so all the high RPC usage from the swap, right? So when would user do the swap? And from our observation, like when there was something big happen on the market, and user will do a lot of swaps, like BTC all-time high, like Donald Trump became the president, or some kind of token hype. But in this kind of situation, the token price usually goes up. But what happens if the price keep going down on the market? So let's say that if Portus is trying to swap from ETH to USDC, and the price Portus provide is 2,600. And then when user accepts the price, when Portus really run the transaction, the price goes down to 2,400. What would happen? So there's a requirement on the CoSwap platform that porters have to fulfill the price we promised at the first, no matter what happened on the market. So which means that if there is a price gap between the quote price and the executed price, then porters will have to pay for it. So let's say if porters have to pay 10 USDC per order, then based on our performance, we have to pay 2,400 USDC per hour, which is pretty scary for us. And what if the token price goes up? And you may ask, will porters make 2,400 USDC per hour? I hope so, yeah. But when the price goes up, the gas cost usually goes up too, right? So this is the gas cost I got a few days ago, and the bottom is the gas price I got last year. So you can see the gas price could go crazy when there's a lot of activity happen on the blockchain. And when that happens, you have to be very careful, because the porters will charge a gas fee to compensate the gas cost from the user. But the gas fee is determined before we do the swap. So if I say I will charge 1 USD from the user for the gas, and when I try to execute the transaction, the gas goes up to 10. And then I have to pay for the extra cost, extra gas cost. And that's another loss for us. So what about a stable market? What if the market is stable and the gas price is stable? Is gas cost a concern? I would say that if you estimate the gas cost precisely, then it will be okay. But how to estimate gas cost precisely? So here are some fundamentals of gas cost on the website of EVM.codes, and you can check them, check all these fundamentals by yourself. But besides all these fundamentals, you may need to know what is initial gas, what is memory cost, and what is an access list, and when would you get a gas refund and other stuff. And all this knowledge can help you to estimate your gas costs more precisely. And after you know all the fundamentals of how to calculate the gas, then you can use a tool on Tenderly called Gas Profiler. So you can run your swap as transaction on Tenderly and see how much gas does it cost. And then this is the example. So, okay. So what if I already know the gas of a swap on a liquid pool? Is there anything I need to be aware of? There's something we found that the gas cost of a liquid pool may not be fixed. It would change based on different kind of conditions. And there was a time that when we tried to do a swap on Uniswap V4 pool, and because there's hook before and after the swap, right? So when we try to estimate our gas cost, because we only provide like the token address, the token amount, we didn't provide the from address. So the from address was 0, and we thought that was okay because it's just for a simulation. But the gas cost we got by using the zero from address, and the gas cost we got by using another real or say non-zero from address is totally different. So this kind of difference will make us to pay for the extra gas. And this is something I think everyone should be aware of. And besides the pool, there's also token we need to be pay attention to. So this is the transfer from function of MOG token. And as you can see, there's a lot of different kind of condition in this contract code. And then you can see there's at least 4. So if any condition met in this contract code, the behavior will be different, which means the gas cost will be different. So you have to find a way to estimate your gas cost as precisely as you can. And talking about ERC20 token, there's another kind of token, it's called fee charge token. And fee charge token is a kind of token that will need to charge a fee when doing the swap. So at the time, porters did not aware of this kind of token, so we did not charge the fee from the user when we provide the price. So, which means that we have to pay the fee for the user, which means another loss for us. So you have to really pay attention to what kind of token you're handling. Okay, so far we've walked through like the how to select your RPC endpoint and how to estimate your gas cost, and there's some unexpected behavior happen no matter it's on the system or on the market. So how do we find anomalies? And what if we don't deal with this kind of anomalies in time? What would happen? So for porters, we collect data from the market and from our system every day, and we try to build a monitor system to monitor a few metrics we set. And when the monitor system finds something weird, and then the system will send out alerts to tell the team to take a look at it. Because if we don't deal with the anomalies in time, there will be a huge chance for us to lose, right? Just like I mentioned before. But in the past, at first we set too many metrics at the moment, and then there were so many message flood in our channel, and there's the most scary part of this is not a lot of message you cannot read. The most scary part of this is that you don't know which one is the true alarm, and then it will easily be ignored by you, and then will cause some kind of tragedy. I don't know. Yeah. And there was a time that a solver on the CloudSwap platform did not handle their anomalies, I don't know, in time or in some kind of situation, but they need to pay the platform 4,000 USDC, which is something we try to avoid. And speaking of data, like I think everyone knows when you're collecting data, there will be a delay, right? You cannot get the data as soon as it showed up. There maybe it depends on your frequency of your system refreshment, or it depends on when the data will be uploaded or when the data will show up. And some kind of data you have to rely on third party, like the data can be only provided by third party people, like maybe we rely on the data provided by CloudSwap team, and the delay of this kind of data may vary from few hours or few days or even sometimes week. Yeah, and in that moment, in the time period, we will lose some sense of the market and our system because we cannot get the data. So that's the very important thing you need to know. Okay, so all talk about this, let's talk about why do you need Porter to do the swap for you. So let's see if, so Porter is a MEV protected solver, which means that if you do the swap with Porters and you don't need to worry about MEV, but what if you do a swap on a swap aggregator, right? You have to take care of the MEV by yourself, and when the gas cost is climbing, Porters will pay the extra gas for you. But what if you do the swap on a swap aggregator? you have to take care of the climbing gas cost, right? And if porters win the chance to fill your order, the best price we provide will be the best price of all 23 solvers on CloudSwap platform. But what if you do the swap on an aggregator? The best price will be the price of all the liquidity pool the aggregator has, right? So, so far we've been walked through all the experience we have and share with everyone in this room. And so for now, Porters is working on enhancing RPC efficiency and developing swap strategy and improving our monitoring system to react to the anomalies more actively. So to address these challenges, we are hiring. We are looking for several roles. So if you are interested, please check our website, porters.xyz, or you can collect our POAP here, or you can find any one of us at our booth and talk to us. Thank you.
All right, any questions that we have? Yes, sir.
Hello, sir. Thank you. Do you do like solve the cross-chain swaps as well? Like when user wants to, let's say, execute Ethereum to USDC, could you show the route also from Ethereum to Arbitrum? Maybe there is a much better route. Are you doing this kind of stuff too?
Because we're a solver on CloudSwap platform, right? So what we can show to user is not decided by us, but I think it's possible for us to if we wonder we become an independent service. So yeah.
Are you planning for that?
There's some planning running, but I don't know when we will execute the plan. So yeah, we will let you know.
Thank you.
Thank you.
All right, any other questions? I do have a question actually.
Sure.
So as solver, right now, mostly you guys work on CalSwap. Is that right?
Yeah.
Are you guys also working on other like platforms?
Mm-hmm.
Because
Mm-hmm.
as I understood, kind of like you have intent-based architectures, right?
Yeah.
And then solvers are kind of like the providers of these, like the real power of like powering these, right? So right now there's a lot of like chain abstraction systems, or all these things are kind of like the same thing, right? They all actually require solvers and then people that has liquidity and can front like, users fronts. So yeah.
Yeah, so our main focus now is on the CloudSwap platform, so there's still a lot of work to do, but we are doing our research to expand to other platforms like maybe OneInch or maybe Uniswap, but it's still under progressing, so you will see us if we finally launch our service on other platform. Mhm.
Right. OneInch and Uniswap is like kind of under the aggregator kind of category. Is that correct? Or
You mean
they have-
Uniswap X?
Oh, Uniswap X. I gotcha. Uniswap X is intent.
Yeah, Uniswap X is intent-based.
Right. Understood. And any plans for like, let's say, there's some others, D-Bridge, and also Across. Across has been quite popular as well. I guess that could be a question for Shenting, right? But yeah, are these kind of like in line? And what do you consider when you choose? Maybe that's kind of like the question, because there's so many architectures around here, right? What do you prioritize in choosing what to integrate first as a solver?
Okay, so as a solver, the priority for us will be how much income we can earn on that platform, because every platform has their own rules, right? And some platform will focus on developing for the future, and then they may not have a lot of reward or bounties for other developers. But for us, the most important thing now is to keep the team survive, especially when we are in a cold market. So yeah, that's our first priority. Mhm.
Understood. Thank you so much. Any other questions that you might have? If not, then thank you so much, Jeff. And once again, the happy hour is sponsored by Portal and amazing beers and amazing food. So do remember to join us after. In the meantime, next up we have Han from Nethermind. Wait, Han? Oh, there we go. It's up. Yes, sir. So Han will be talking about how SnapSync works on Ethereum and StarkNet.
Okay, I think we'll settle down a little bit. Yeah. So just a quick warm-up, because I believe this talk and the next talk will be core protocol development things. So it might be boring to some of you, or it might be very interesting if you work on corpo like myself. I'm just curious, like, if anyone runs a node on Ethereum, whether it's testnet or mainnet. Anyone? Okay, I see one there. Only one? Okay. I expected more, but it's fine. I know it's hard to run a node, but anyways, like I personally run a node on Ethereum mainnet and testnet, and definitely also Starknet. And I remember my first experience running a node 2 years ago was when I had to gather a bunch of hardware, making sure that my network setup is right. And when I finally got everything right, I pressed the start button. So I expected it to sync for a day, but to my surprise, it actually took 30 days and actually even more. So then I wondered, like, is there a better way of syncing? Like, no, definitely I was very surprised that, I was very happy that my node is synced after 30 days, but to me at that time, it just feels very slow. So I did some digging to my setup, and I realized I was running on a configuration called full sync, not SnapSync. So after that, I think after a few weeks, I bought another pair of machine. I had the same exact setup, and then I ran it on SnapSync. And I managed to sync the node in just under a week. So that's how powerful SnapSync is as compared to the regular full syncing experience. I'll explain what those things means later on. But at the same time, I do not want to trick you to think that SnapSync is the end game solution. SnapSync is the best way of syncing a node on any blockchain or anything else, because in fact it's not. And there are much better syncing algorithms out there. And at the end of today's talk, I'm also going to share with you how the future of syncing looks like. But without further ado, let's dive a little bit deeper into how SnapSync works on Ethereum. So first, let's think from first principles, like why do you even have to sync a node, like when you run a node? So typically on a blockchain system, you would have two roles, two actors in general, or two important ones. You have the block producer, and then you also have the block validator. So basically, as the name implies, block producer proposes a block or produces a block, and then the block validator basically would validate a block. So just assuming that the system is this diagram, you only have these two actors without anything else. It's basically a trust me both system, because you're just the block validator would be just trusting whatever block that it receives. But of course, it's a blockchain, so we don't want to have this kind of trust me both system. This is where we get the I don't trust you, that kind of thing. That's where you have to verify if the block is correct or not. So in order to verify if a block is correct, you basically have to introduce something called a state, right? So both the block producer and the block validator have to have the right state and also the latest one. So in order, for example, for block producer, they need the latest state in order to produce the right results. And for block validator, they need the latest state in order to validate that this is correct. So now, again, from first principles, what exactly is the state? On Ethereum, the fundamental data objects are basically these two things, accounts and slot values. So an account, two types, EOAs and contract account. So EOAs are externally owned account, basically your regular account with just the balance and also nonce. And then you have contract, which is your contract. And so for each contract, it will also have its own slot values. So two fundamental data objects, account and slot value. And how are these objects being represented? Is by using a cryptographic structure called TRI, or Merkle-Patricia TRI, or to be even more specific, hexary Merkle-Patricia TRI. This diagram is a binary one to make it simple, but in actual cases, it's actually a hexary Merkle-Patricia TRI or hexary MPT. So you start off by having the state TRI, or other people may call it the account trie. So in the leaves of the state trie, you would get all of the accounts. So account contain balance, nonce, root hash, and code hash. And then for each of the contract account, you would get the storage trie, right? And the leaves of this storage trie will basically contain all of the slot values, 32 bytes, raw bytes, right? So this is how a state is being represented. So when people mention, yeah, we need the state, we need the state, we need the state to sync, it's basically, what they mean is basically we need the latest state trie to sync, right? So this is the kind of the general picture of what we need. Now, let's talk about full sync, or let's talk about one of the most naive approach when it comes to syncing a node, which is, we call it full sync. So how full sync works is, again, very naive. You start from zero, you start from scratch, you start from the genesis. You take the genesis block, you execute it, you get a state, and then you take the next block, which is block number 1, you execute it, you get the next state, and then you keep doing it as the chain progresses and until you have reached the latest state or latest block, right? So as I say, this is naive, and the problem with this is it's way too slow. If you attempt to do this on, for example, someone at a low-end machine or a Raspberry Pi, that kind of setup, doing a full sync will probably take you, from my experience nowadays, I think probably about 2 months, 2 to 3 months. So it's way too slow. But if you have to run an archive node, then you have no choice. Using Go Ethereum or Nethermind, if you are using Aragon or Ref, or yeah, these two clients, then they have their own syncing mechanism, which is much faster, but okay, I'm not gonna talk more about them because I don't know much about how they sync, but anyways, yeah, it's too slow. So going back to the goal of syncing, right? The ultimate goal of syncing is just we want the state trie. And to be more specific, we want the latest state trie. So how can we do that without executing block by block? And the answer is step sync. So how does step sync work? So first step is that you will select a pivot block. So a pivot block is basically you want to sync up until a certain point in time. Time means in terms of measured in block height. So this is usually the last finalized block, not the latest block. Why is it not the latest block? Very simple. Because if you choose the latest block, if you choose the latest block, this latest block that you have chosen could be reorged. So when it reorgs, that means if you have downloaded the state, you have to revert the state. So, and you revert the state and then you choose the second, you choose another latest block, and there's a chance that it might get reorged again, then you have to do the reverting process again. So this back and forth reverting kind of thing isn't ideal when it comes to engineering. It's not efficient, it's not effective. That's why you usually would choose the last finalized block because it's less likely to be reorged. But if in the worst case it is reorged, then the process, the step sync process will become very expensive in terms of the reverting process. Yeah. So anyways, choose a pivot block. Next, you would have to download the leaf ranges. So what do you mean by leaf ranges? A leaf here means, again, the fundamental data object, account or slot. So leaf ranges means it's either account range or a slot range. So a range is basically a range of accounts from one address to another address. So for example, the requester will request for the accounts for example, address 1 to address 3, right? So that is a range of 1 to 3. So the requestee will send back the actual account objects back to the requester from account 1, address 1 to address 3. So that is a range. So assuming that the current Ethereum state trie contains account from address 1 to address 10,000. If the requester has the account from 1 to 10,000, he or she can reconstruct the entire state trie, right? Because that's how the objects are being represented. But there's one caveat here. What if the requestee is malicious? Or what if it sends back a false value, right? So there must be some way to prove that this range is correct, and that's where we need a proving mechanism. And here, the proof that we use is called range proof. So Yeah, so the range proof will prove that this range is correct. To dive deeper into how does a range proof look like, let's give an example. So assuming that on the left side, you have the try, yeah, and then the account range that is being requested is from address 1 to address 4. So first step on generating the range proof is you're going to prove the left side, meaning to prove the first item or the first account in the range. So here you will generate a Merkle proof for the left side, and then you're going to generate a Merkle proof for the right side. So here in this example is account 4, which is the last item in the range. And then a range proof is basically merging these Merkle proofs together. So this is how a range proof will look like. So it's kind of like a partial view of the try. So this is a range proof. In terms of the verification part, now you have two things. You have the range, you have the range proof. So in order to validate if this range is correct, you simply insert these values into the range proof, right? So again, now this becomes a slightly even more complete view of the entire state try. So to validate if this is correct, you basically check the root hash. So if it's a state try, you check if the root hash of this partial try that you have just reconstructed matches the one in the block, or if it's a contract try, then you will check if it matches the one in the account, right? So what happens if one of the values is false? So you basically get a mismatched root hash. So what will happen is you will reject this range, you will reject this response, and you probably would ban this peer because it sends you a false range. So that is a very simplified version of range proof. So after verification, if it's correct, the requester will simply persist the range into the database, and this process would repeat until all of the ranges has been downloaded. So yeah, that's kind of it for SnapSync. So it's actually much simpler than you might have thought, or is it? Not really, because there are a few more issues that we have to address. The first issue is pivot block constantly changes. So the pivot block, so last finalized block, it means that latest block minus 64, something like that, usually. So it's practically or almost impossible that you have downloaded all of the available state, meaning accounts or slots, within this period, or in this pivot block. It's practically impossible. So the pivot block would change, would definitely change, and when it changes, that means that the state you have downloaded before, they could be outdated, and there could be some missing gaps in your current available downloaded state. So that's one of the issues that we have to address. The second issue that we have to address is that we want the latest state, right? So because again, we are only requesting up until pivot block because of reorg issues, but this is still our final goal. So we have to introduce an additional phase called healing. So the healing process is that you have already downloaded all of the range, you have reconstructed the try up until a certain point. Some of them are outdated, and then you compare it with the latest state try, right? So you will see some, you will get some missing gaps or outdated values. So the solution to this is actually very simple. You simply request for the missing try nodes, right? So the requesters would request for the missing try nodes, and the requestee will send back the try nodes. And then you would replace the outdated ones or fill up the missing ones. So one very important thing when it comes to SnapSync during this phase is that you have to have a good network setup and also a good hardware setup such that you are able to heal much faster than the chain progresses. Because if you can't heal that fast, you will forever be in the healing phase, forever, stuck in the loop. And that's why when you go into like Go Ethereum Discord or go into Nethermind Discord, even check their hardware specification, they always emphasize a few things. One is that you need to have a certain amount of network bandwidth. The second thing is that you must use SSD. I don't think anyone can sync a node in using an HDD anymore. Maybe you can be 2 years before or even 3 years before, but nowadays it's practically impossible. So yeah, to recap, SnapSync 5 steps, select a pivot block, download all of the ranges plus the range proof up until that pivot block, verify the range, persist the range in the database, and then once everything is done, perform state healing, make sure it's fast enough such that you can reconstruct the state to catch up with the latest chain head. And from there, once you have caught up with the latest chain head, you can then do the regular syncing by executing block by block. So yeah, this is step sync. Next, step sync on StarkNet. So, or any other layer 2 that uses a similar trie structure. So a quick introduction of what StarkNet is. It is a validity rollup, or some people may call it ZK rollup. And it uses Stark proofs, as the name implies. So how would it work on StarkNet, or how would it work in L2s? First, let's understand the differences between Ethereum state and also StarkNet state. So this is how actual state trie on Ethereum will look like. It's a hex array MPT, as I mentioned. And on StarkNet, it actually uses a binary MPT. So, but there are 2 things here. I mean, 2 tries. One trie is called contract trie. So a contract trie is the exact same thing as the state trie on Ethereum. There's a second trie called class trie, which I won't dive deeper into it. But just remember that there are 2 tries. So how the step sync process will work is generally works the same. Yeah, I don't have an interesting answer for you because it's trie structure. Step sync is to download trie. It's a protocol to download trie. So since we are still using a MPT structure, then it should generally work the same. A few things that are different are hash functions, state structure, and trie structure. And one more additional fun thing that L2s can usually do is to leverage on the state diffs posted on L1s. I mean L1. So for example, since we post the state diffs to via call data or blobs, so what L2 nodes can do is to extract these state diffs, decode them, and get the actual state diffs. And those would basically be a partial range. Right, you can use that as a range and persist in the database as well. So that's one of the things that can be done. But other things in terms of the general protocol flow, it should work the same. Now, the fun part, or the final part, which is the future of syncing. How would syncing look like for those who are running nodes? Will we have a better syncing algorithm? And my answer to this question is that ultimately, we will go into stateless sync. Okay, let the name sink into you a little bit. It's called stateless sync. And throughout the past 10 minutes, I have been talking about syncing to get the latest state. But now I'm talking about getting stateless sync to work in the future. This is the end goal. So how do we make sense of this? So in the future, very near future, maybe 2 years or 3 years, or even this year, we might have some demo. How stateless clients will work is that anyone can basically take a block without any prerequisites. You can execute the block and progresses with the chain. Why is that so? It's because in the future on Ethereum, if we actually go with the roadmap, the blocks will contain proofs, or what we call as witnesses, to prove that the state changes given in this block is valid. So that means, again, a block is a single execution unit, so we don't need the state anymore. Hence, this is why it's called stateless. Why it's good for us is because if you want to do block validation, you can simply run a node without any state. But if you want to produce a block, you still have to have predefined state. So this complements very well with proposals like EPBS, Proposal Builder Separation, where if you are just only interested in validating the chain with staking, you can just run a block validator, and your node will have a much, much lower hardware setup because you don't need the state, right? So that will also mean that it may be possible that we can run an Ethereum node just on our phone because the hardware requirement is just so much lower. So this is a roadmap that I'm very excited for on Ethereum. If you want to know more about stateless clients or stateless roadmap, go check out stateless.fyi. This is an official documentation given by the Ethereum Foundation, specifically the stateless consensus team. So yeah, that's all. And I'm an engineer working in Nethermind. I particularly work on Starknet client called Juno. So if you want to talk to me about clients, protocol development, or just blockchain in general, do let me know. And thank you all for listening. Thank you.
All right, we have quite some time for questions. Any questions? Yes, sir.
Hi, thank you. Great talk. So as a user, is there any difference when making an RPC call?
RPC call?
RPC call to a SnapSync server versus the full node server.
No, all the RPCs should work the same. Yeah, there shouldn't be any differences. But the difference of the RPCs would differ depending on the type of the node. So there's few types: light node, full node, archive node, or some maybe stateless node as well. So if we focus on full node and archive node. So for full node, for archive node, it can answer all of the RPC calls. But for full node, it might not be able to answer some of the questions. For example, what is my account balance at block 100? So block 100 is like many years ago. So it definitely wouldn't be able to answer that. And maybe one of the calls could be get proof. So if get proof, so for full node on Geth and maybe also on Nethermind, it can only give you the proof up until 128 blocks before. So anything beyond that, you cannot get a proof for it. So yeah.
Okay, got it. So there's no performance difference.
Performance difference, no.
Okay. Another question. I'm curious about what is the hardware requirement for running a SnapSync node?
Hardware requirement for running a SnapSync node? Oh, wow, I can't think of it. I mean, I can't recall it right now, but because they recently came up with not really, is it EIP? Like an official documentation to upgrade the hardware requirement. I believe it's 32 gig RAM, 4 terabytes SSD, 50 megabytes per second network, and yeah, and I think also some CPU recommendations or yeah, so somewhere along that line. There's some documentation online, but I'm still using the old one, which is 16 gigabytes of RAM and 2 terabytes of SSD. I might have to upgrade my hardware soon, but yeah.
Okay, got it. So it's much easier than running a full node.
If you value syncing time, yes. If you want to sync your node much faster, please use SnapSync and don't torture yourself using full sync.
Okay, thank you.
Any other questions? Cool. I have some questions actually. So kind of like, if you're gonna do like a TLDR, like SnapSync fast, right? Is there a downside to it?
The downside is that it's usually very CPU intensive. It's very resource intensive. So for Go Ethereum node, it's usually more stable. For Nethermind node, it's usually less stable because, I mean, based on my experience, 2 years ago, but nowadays I think it's much more stable. Because last time when I ran SnapSync on Nethermind on a slightly low end setup, it actually crashes because due to memory issues. But I think it will be it's more stable nowadays. But nonetheless, it's still going to be it's definitely going to take up all of your RAM, all of your CPU because it wants to be fast. There are a lot of things going on behind the scenes when you are snap syncing. So yeah.
I see. Then perhaps on the question from another perspective, which is the users, right? So for the users who want to sync nodes, typically there are developers or like miners, right? For miners, you mentioned in the future, we might be just using the stateless ones. But who would be using just kind of like from your perspective, who would be using snap syncs later and other kind of syncs?
So I think the roadmap is that we will go with PBS, proposal builder separation. So that means there will be a clear separation between proposal and builder on a protocol level. So for someone like me who doesn't care about MEV, I don't want to extract MEV when I run a validator node, then I just want to validate if the chain is correct. Then I will run a stateless client to just validate the chain. And it's going to be much easier for me. The hardware setup is going to be much lighter. The commands or the instructions is going to be much better. That means the user experience is also going to be much better. So that will be one of the user profile. And then for block producers who are typically institutions who, quants who want to do some MEV stuff, or even RPC providers, then they will want to run the regular snap sync process rather than a stateless sync. So yeah, I think that would be quite interesting to see.
Awesome. Just want to make sure there's no other questions. Any other? All right, one last from me. Actually, I have a lot of questions. It's great talk, and so I'm very interested. One question that I have essentially is also coming from the user side. So as a user, like so I'm sort of ignorant on the node side of things. I'm more on the Solidity and just like the smart contract side. So it would be good to have your input. My understanding is that wallets, at the end of the day, we hope to have like light node. But is that practical nowadays? And do you see, like ideally it should be able to run on my mobile phone, right? But is it practical nowadays? And then, like how is it looking in the
Now, definitely no, with the current syncing mechanism or whatever protocol rules that we have. But as I said, stateless would start to enable this road or this opportunity. But I do see, like my goal is also that such that I want to be able to validate on my phone. I think stateless clients will be able to enable that in terms of the hardware side, but in terms of the networking side, it would have some issue because mobile devices, for my knowledge, mobile devices are bad when it comes to P2P networks. So that might be another hurdle that we have to overcome. But at least on the hardware side, at least on the execution side, it's kind of fixed. But on the networking side, we might have to solve it later on. But it's definitely feasible once we have stateless clients, hopefully in 2 years, optimistically, yeah.
Which brings me to an interesting follow-up question. I promise that this is the last one. I keep saying the last, but it's too interesting. So you mentioned that like on this direction, basically the stateless one will be enabling the mobile one, but on the light client, my understanding is that it still needed some state for that, or no, completely don't.
Light side, I'm not sure if light client is even needed after we have stateless. Yeah, I can't think of why. Maybe there are some users who want that, but I'm not sure why, because a light client ultimately relies on a full node to do validation correctly. So if you already have a stateless client, then why would you run a light node? So yeah, maybe there are some things that I've never thought of deeply, but personally, I don't think people will run a light node anymore after that, but yeah.
Interesting. That's very great insight. Essentially, after the stateless is ready, then light client is basically replaced by that. Should be, like per current understanding. And
current understanding, yes.
Per current understanding, which means that could be an interesting topic to dive into later, and then talk about in the next ETH Taipei or regular meetups. So let's thanks Han for the wonderful presentation. And next up, we have Jeff from Curve Grid, and is going to present who's Blob and who's Alice, though.
That's a great question. Good afternoon, everyone. How's everyone doing? Last session of the day, last session of the conference. Let me just get plugged in here. Wonderful, thank you. Okay, I think we're good. There we go. Let me rearrange the cables here. Slideshow mode. Slideshow mode. There we go. Excellent. Good afternoon, everyone. My name is Jeff Wentworth. How's everyone doing? How's the conference been so far? Good? Excellent. Can I get a big, big round of applause and thank you for the organizing team, the ETH Taipei organizing team, all the volunteers, staff. Tremendous couple days. Thank you. Thank you. And thanks to all of you for sticking around, of course, for this last session. This is Who's Blob? First, a little bit about me for just 30 seconds. My name's Jeff Wentworth. I grew up in Canada, but I've been living in Japan for the last 18 years, where we co-founded CurveGrid. I have an engineering background. You may be wondering, what is CurveGrid? Please do check us out on Twitter there. We are a blockchain development platform company. Our product is called Multibass. It's a platform that allows you to build blockchain applications up to 10 times faster than doing everything from scratch. It combines all of these different components: cloud wallets, transaction manager, webhooks, event indexing, plugins, SDKs, all behind a very easy to use web UI and REST API. We are co-sponsoring ETH Global Hackathon this weekend, so if you are building at ETH Global, please come build with us. We'd love for you to come and win some of our prizes and win some of the overall prizes. Okay, so that's me and CurveGrid. Let's talk about blobs. So before we go into blobs, we need to do a really fast Ethereum 2.0 recap. Then we're going to talk about what blobs are. We'll talk about the blob fee market, blob components. We'll do a sample blob transaction. And we'll talk a little bit about how L2s use blobs today and how they plan to use them in the future. So how many people here are familiar with this diagram? This diagram describes the Ethereum 1.0 to 2.0 upgrade, or the merge. How many people have seen this diagram or a diagram like this before? Okay, like maybe 15 to 20%. Okay, that's great. So I'm going to go through this really quickly just to help set the stage, because it's important to understand a little bit about this, to understand a little bit about blobs. So two parts. First of all, the Ethereum evolution itself. Originally, we had proof of work, right, which contained both proof of work itself as well as the Ethereum state. And then in late 2020, Ethereum booted up the Beacon chain. And the Beacon chain was basically the proof of stake component that was being incubated and developed and worked on for a period of about 2 years until the merge happened in September 2022, right? And at that point, the Beacon chain became the Ethereum chain. And we moved from proof of work to proof of stake. So proof of stake along with the Ethereum stake. And again, these two different consensus mechanisms. Proof of work, as you all are very familiar with, I'm sure, where miners solve a very complex mathematical puzzle, and block time varies, sometimes between 10 to 15, somewhere between 10 to 15 seconds, depending on mining difficulty. And proof of stake, validators now deposit 32 ETH each. Of course, that's soon to be increased. Validators are randomly selected, and it's a fixed slot time of 12 seconds. The Beacon chain itself. So the Beacon chain is the Ethereum chain today. A slot is there's one slot exactly every 12 seconds. It may or may not contain a block, and an epoch contains 32 slots and is exactly 6.4 minutes long. You can see here in the bottom diagram that as we move through the epochs, you go from finalized to justified to proposed slots and the blocks that they may or may not contain. And then the diagram on the right there, we have pre-merge, where basically we were only concerned with the execution layer existing inside of proof of work. And post-merge, we now have the execution layer sitting inside of this consensus layer. So what are these layers? The consensus layer consists of the proof of stake consensus algorithm, which receives and propagates blocks. And the execution layer is all about listening for new transactions that are broadcast across the network, executing them inside of the EVM, and it holds the latest state of all the current Ethereum data. You can see here in sort of this sequence diagram, right? You have now this consensus layer and execution layer. And if we look at what this looks like from a client or API perspective, right? The actual software that's running on our Ethereum client or Ethereum node. If you are a blockchain application developer, you may only care about the execution client or the execution engine. But there is also a separate piece of software that Ethereum validators are running called the Beacon client or Beacon node. The two of these pieces of software together, and they're separate pieces of software, are running inside of your validator client and make up a complete Ethereum client, right? So you may be interacting, you would interact with the execution engine or the execution client through Web3 ETH, your classic JSON RPC, and then there's a REST API connection into the Beacon node. And you'll note that both the Beacon node and the execution engine are communicating peer-to-peer over the Ethereum blockchain network. Again, the Beacon node is primarily concerned with blocks, and the execution engine is primarily concerned with transactions. This is going to become important in a minute. So we're still sort of setting the stage here for blobs, right? And again, listing some of the popular consensus and execution clients, which I'm sure you all heard of, and obviously we just had Han from Nethermind speaking right before me. Okay, so who is Blob? Blobs were introduced really with EIP 4844, also called proto-dank sharding. And when I first heard about proto-dank sharding, I thought the emphasis was on the word dank, which means kind of musty or moldy, but actually it's the name of an Ethereum researcher, Dankred Feist, who came up with this. So I was quickly corrected there. So proto-dank sharding equals EIP 4844 equals blobs. These were included in the Cancun DNEB upgrade, which went live just over a year ago. And obviously it's available across Ethereum today. So it added a new transaction type, right? So previously we had legacy transactions, and then with EIP 1559, we had dynamic fee transactions. Now we also have blob transactions. And as Vitalik mentioned yesterday, there's currently actually it's a target of 3 blocks, but a max of 6 blobs per block, and that's soon to be increased with Pectra. And we just finished talking about the Beacon node, the execution engine. Blobs are persisted in the Beacon node. They're also pruned or deleted after 4,096 epochs, or roughly 18 days. So blob data is thrown out every, a little bit more than every 2 weeks. And crucially, blob data is not included in blocks. So where is blob data included? Where does it sit? Well, we'll get to that. I want to talk a little bit about the blob fee market. And I'm going to introduce it here, and then I'm going to show you a real-world example of what this actually means and why we introduced blobs in the first place, because a lot of it has to do with cost and efficiency in the Ethereum protocol. So along with the introduction of blobs and proto-dank sharding and EIP 4844, there was the introduction of blob gas as this new type of gas. So it's independent of normal transaction gas. This minimum amount still needs to be paid, but it follows its own targeting rule, very similar to EIP 1559. Right, so there's about 131K of gas per blob. Again, I mentioned this before, but target blobs per block are 3, maximum of 6, and it's a slightly different base fee formula. So you could think of this as kind of a multi-dimensional fee market, and you can see here in the diagram, right, this submitted transaction on the left is the entirety of the transaction, right? So we still have our max fee with our max priority fee, and then according to the fee market, the fee auction market, if you will, for the regular portion of the transaction, we will have basically the base fee paid, potentially a refund, and then the priority fee. And then it's the same thing for a blob fee, except we don't have this kind of priority fee. So what are blobs used for? Well, primarily for storing layer 2 rollup data, although we'll show in a little bit that that doesn't necessarily have to be the case. Basically, like, the blockchain transaction cost is related to the amount of data that you need to store on the blockchain, who needs to store it, how many copies are stored, and how long you're storing it for. So Ethereum has traditionally been expensive for transactions because you've had to store all of the transaction data across all of the blockchain nodes forever. So one of the trade-offs that L2s make in order to offer much cheaper transaction fees is offloading some of the security around how long and where the data is stored to their companion layer ones, right? They basically do this by being more centralized and posting guarantees back to the L1 on a regular basis. So again, here we have our layer 1 blockchain, let's say Ethereum. We have our validators. We have our blocks, block 0, block 1, block 2, and our associated transactions per block. And then we have our layer 2 blockchain with its own transactions. And I've numbered the transactions on the layer 1 blockchain to make them distinct from the labeled transactions on the layer 2 blockchain, A, B, C, etc., down to ZZ. And on the left-hand side on the layer 1 blockchain, we have our validators. On the right-hand side on the layer 2 blockchain, we have our centralized sequencer, right? Singular. The transactions on the layer 2 blockchain are all rolled up or summarized and posted into transactions on the layer 1 blockchain. So let's take a look at just over a year ago, right, which is just before proto-dank sharding came into effect, just before 4844 came into effect. This is an example of a Uniswap transaction on Ethereum where the transaction fee that was paid was $12.50, right? So obviously things are much cheaper today, but let's take a look at a transaction from a year ago. A similar transaction on Optimism, a layer 2 blockchain, at the same time, similar kind of DeFi transaction only cost 38 cents, right? So $12.50 and 38 cents. Obviously layer 2 transactions being much cheaper, right? Because of a different trade-off in security guarantees and the amount of data that they have to store. Now this is a blob transaction, but it's not a modern blob transaction, it's a legacy historical type of blob transaction from just over a year ago, where the Optimism batcher was posting its blob data, its 128 kilobytes of blob data, into a standard Ethereum transaction. And at that time, they paid about $180 for this summarized blob data as a standard Ethereum transaction. And in fact, if we go back, and I have this screenshot saved from just over a year ago, if we take a look at the top gas guzzlers or gas spenders on mainnet Ethereum in early 2024, 4 of the top 10, let's say, were layer 2s that were spending a combined $798,000 per day just posting their proofs back to L1 Ethereum as standard transactions. That's $298 million per year. Like that's a substantial amount of money that it was costing these layer 2s to post transactions back to the layer 1 as standard transactions. So fast forward a year, this is a same now Optimism batcher posting summarized transactions as blobs. This is a blob transaction from, I think, yesterday. And instead of $180, it's only paying $40. Now, of course, there's liberties taken with time and space and exchange rate and gas prices and things like that. But basically, the whole thing here is expensive layer 1 transactions, cheap layer 2 transactions. If I post my rolled up or summarized transactions from my layer 2 onto my layer 1, it's expensive, but as blobs, it becomes much cheaper. So that's really what was driving the innovation in blobs. Money and cost. Okay, so now let's get into blob components. So there's really 4 kind of things to think about here, and these aren't all parts of a blob, but these are all concepts associated with blobs that are important to understand. And we're going to describe where all of these sit in this next section. So the first piece is the blob data, right? This is the opaque content of the layer 2 transaction batches that is the blob itself. Then we have what are called the KZG commitments or a polynomial commitment. This is also called the blob hash, and this is available in the EVM. You can actually retrieve these within Solidity from the transaction, from the code that runs within the blob transaction itself. And KZG stands for the initials of the 3 authors of the 2000 paper that figured out these polynomial commitments. Related to that, we have KZG proofs. And these are used to prove data was in a blob. This can be done off-chain or in smart contracts through some sort of solver or prover that runs iteratively on the blockchain using a lot of math that is way above my capability as a computer engineer. But I think all the computer scientists would be able to dive into this. And then we have this concept called the sidecar. And this is let's say, a technical term in this whole blob construct. And the sidecar is off-chain data structure of a blob and its metadata. So blob data, KZG commitments, KZG proofs, and the sidecar. So this is a picture of a motorcycle and its sidecar. For any of you who are wondering what a sidecar is and where they got the terminology from. Now, obviously, this is a picture from the movie Indiana Jones and the Last Crusade. Harrison Ford is Indiana Jones, and Sean Connery as his father, Dr. Jones. So as I like to say, maybe we shouldn't call this sidecar, but we should do it in a Sean Connery accent and call it a shidecar. Thank you. And so what you can think of here is, in this analogy, in this visual analogy, we have the motorcycle is really the block with the blob hash, and the blob is the sidecar. And the sidecar, again, it's a technical term that's used inside of the Ethereum ecosystem, inside of the beacon clients. This is really divided between the execution and the consensus clients, right? Or execution layer and the consensus layer. Again, so the block is on the execution side and the blob hash side, whereas the blob is sitting in the sidecar and the consensus layer. 2 weeks later, or 18 days later, 4,096 epochs later, we throw away the sidecar and we're just left with the block and the blob hash. And so that's how we remain efficient with this. We have all of this blob data that we had kept around for 18 days, propagated globally. Anybody who needed to do something with it did something with it, whether it was validating the fact that a layer 2 was doing the right thing, or saving it for later, caching it for later. But there's only a guarantee that that sidecar data would be around for 18 days. All right, should we do a sample blob transaction? Who wants to do a sample blob transaction? Anyone? Yeah? All right, should we do this? All right, let's do a sample blob transaction. All right. Okay, so we're gonna jump into some code here. Can everyone see this okay? Yes? Excellent. Okay, so this is a very simple proto hack sharding program that I wrote to test proto dank sharding. We're going to compose, sign, and send a test EIP 4844 transaction with some placeholder blob data. So I'm just going to describe what this code is doing. Obviously, what layer 2s are doing, what the sequencers are doing is a lot more complicated, but I thought this might be interesting to kind of dive in here a little bit. Okay, so the first thing we do is use everyone's favorite, this is in Golang, by the way. So the first thing we do is use everyone's favorite Golang configuration parsing library gofig and pull out all of the related configuration values. We then create the blob in this message to blob function. And so basically what we do here is very quickly we're into this KZG4844 library that's inside of Go Ethereum that's basically turning our blob into a KZG commitment. It's then computing the proof from that commitment. And at this point, we have basically everything that we need to go and compute the blob transaction. Okay, so we've done message to blob. Now we start to construct the sidecar. And I wasn't joking when I said that sidecar is a real technical term. There it is there inside of Go Ethereum. So we construct the sidecar itself with the blobs. Here's just a single one, single commitment, single proof. And then we start dialing up our Ethereum node. So we dial up the Ethereum node, we pull out the network ID, which we need to compute the actual Ethereum transaction. We load in our private key and set up our signer. And then we start to put together our blob transaction. So as I mentioned, there's legacy transactions, dynamic fee transactions, and now blob transactions. There's a couple of others as well, but here's our blob transaction with many of the typical fields that you would find, but also now the blob fee cap and the blob hashes in there, along with the sidecar. A few different housekeeping pieces around setting up the transaction. We now go and sign it with our private key. And we're just going to output it then, and then we send the transaction to the blockchain. All right, shall we do this? Let's do this. All right, so the first thing I'm going to need is an ENS address. Who here wants to share their ENS address with me? And you are going to be the recipient of one brand new blob on Sepolia today. Anyone? Anyone? Yes, what's your ENS address? It'll work on Sepolia. Martin? Hold on, Martin, what's that? VOL. Is this you? All right. It's a great photo, excellent. You've got everything linked here, that's perfect. Okay, this looks like your address, right? Yeah? Okay, so OXF1239, et cetera, We're gonna go to our command line. We're gonna fire up our proto hack sharder here. Okay, so proto hack sharding dash to address. I mean, live demos are always so exciting, aren't they? Okay, here we go. Ready? All right, let's see if our Ethereum node, proto hack sharding, and Wi-Fi all work together. Let's do this. We're composing, signing. Yes, yes. Okay, here we go. Excellent. All right. I see a transaction coming up on Sepolia. It's mining. Come on, everyone. Let's get it up for Sepolia. Sepolia, 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 Sepolia. Come on, let's give it a little test now, a little of encouragement here. Looks like it's been mined. It's in our secondary node. Okay, we're going to give that a second. Excellent. Now, while this is coming up, give it a second. I'm going to not wait for this. I'm going to go back to one that I mined earlier today. And I'm going to show you on Etherscan, which we're all familiar with, right? This is a blob transaction. You can see that it's missing all of the usual fields that you might see here in a typical transaction, but we do have transaction action, commit 4844 blob. So if you manage to find a blob transaction in the wild on Etherscan, it will look like this. Let's come back here. Okay, here we go. 2-block confirmation. So here is our blob transaction. Where is our blob itself? Yes. Congratulations, Martin. Proud owner of a new blob. All right. We also have a separate explorer here called BlobScan. How many people here have heard of BlobScan? Yes. Okay. Handful. Excellent. So here is Martin's blob coming up on BlobScan. And you can see that it's been finalized. We have our commitment, our proof, and transactions and blocks. And it's interesting here. It's available in a few different blocks because I basically submitted the same blob proof multiple times with the same message. Now that would not normally happen, but that is the case here. Okay, so here's your blob data, Martin, and it's mostly zeros, but let's turn it to UTF-8 and hello, ETH Taipei 2025, let's blob. There we go. Excellent, Martin. Now, you can only keep this for 18 days, but for 18 days, this blob is yours. All right, back to the presentation. So that's our sample blob transaction. We're gonna wrap up here in a second. Okay, so let's talk just briefly about how L2s are using blobs today. So we talked about this a little bit earlier as well, but again, L2s are publishing block transactions to batches to Ethereum. And then smart contracts are able to access these commitments via the TX block hash built-in function or array or property inside of Solidity. So blobs, as we can see, have already started to reduce gas costs because instead of using call data, we're now using blobs, but we're not quite yet all the way there. They're not yet used for withdrawals, forced transactions, fraud proofs. All of that is still handled as it was before. But that's what we're looking to for the future. If you spend time on L2Beat or looking at any of the kind of the research that's being done in any of the L2 stacks, Optimism or Arbitrum or ZK EVM. This is really the future, right? So the idea is eventually to give us the ability to use blobs to decentralize sequencers, to verify data inclusion with KZG proofs and the blob hash, really, as I think Vitalik mentioned this morning, give us this kind of walk-away security, where everything else can fall apart. A layer 2 could cease to operate or cease to operate reliably, along with all of its infrastructure, and we could still use what we had on-chain and what we had stored from our transactions to be able to reliably post transactions to L2s, exit from them, basically make the blockchain world a much better place. So that's it. That's it. Thank you very much. Any questions? Do we have time for questions? Okay, we have a couple minutes for questions. Any questions? Yes, for Martin.
Sorry, gonna run really fast all the way. There we go.
Hello, thanks a lot for the blob. Just wanted to ask, after the activation of proto-dunk sharding, did we actually see the fees on the L2s get lower? Because the L1 data fee should be lower on those, like Optimism and such?
Yeah, it's a great question. Like, I very much hand-waved over a lot of that. And I think there's been cases, because I believe there have been cases in the past months where because there's been so much, every L2 has retooled to use blobs. And so now there's been cases where blob space has become more expensive than L1 call data space, I believe in some cases. And there was actually a good post the other day, I can share it later if you like, around changing basically how the relationship between the L1 fee market and the blob fee market to ensure that the blob fee market is basically always cheaper than the L1 fee market, so that like you don't have that kind of like strange inversion and misaligned incentives. I don't know if that answered your question.
Yeah.
But okay.
And as a follow-up, if I wanted to access a blob after the 18 days, was it? The only way will be an archive node if I wanted to verify an L2? It
wouldn't even be on an archive node. You would have to go to some sort of third-party service, either that you're running yourself, right? If you're like you need the blobs for something and you're basically caching them as they're coming in. Or there are third-party services that are basically storing all of the blob data and keeping it forever. And so you could go and pull the data from one of them if you needed.
Thank you.
All right, awesome. Any other questions? No, I do have some questions, sir. So as your current like research and all that, how do you see like the fee market of blob would change? You mentioned already like one potential aspect already, right? And I think one of the factor is like there's so many L2s using that, and then it's competitive. One aspect you mentioned was to make sure the L1 is always more expensive. The transaction fees are more expensive than the blob ones, right? But also, like from my kind of like understanding, there's also like talks about combining different L2s and posting, or like, like if you have any comments on that.
Yeah, it's a good question, right? So I mean, if we go back and we take a look at blob scan here, I mean, you can just see that basically like we're very, very full on blob space, right? So here's Optimism, four blobs, right? 4 blob transactions inside of this block. You could sort of scroll through this and see all the usual suspects between Optimism, Base, Arbitrum, et cetera, et cetera, et cetera. And some of them obviously aren't tagged here. But like the blob space is quite full at this point. And so, yeah, I think there's like, without getting into any of the politics, but just to touch on it, there's let's say the $298 million per year of notional value that Ethereum L1 has now saved blobs, right? Like, what is the right, if everything moves to L2s and L2s are paying cheaper and cheaper fees on Ethereum L1, like where does the economic security or incentivization from it, to secure Ethereum as an L1 or use Ethereum as an L1 come from? And I think, like, I'm not an economist at all, but I think that's another part of this equation that's kind of driving all of the debate in the Ethereum ecosystem now, right? Like, we want to increase the blob size and make it go from 375 kilobytes to 768, beyond that up to 64 megabytes. But does that mean that Ethereum as an L1 just becomes irrelevant, or maybe it turns into something, or into a different kind of relevancy? But what does that mean? The other aspect to all of this is, like, nothing comes for free, right? We've seen this in some blockchains where they've forked Ethereum, let's say, and just greatly increased the gas limits, right? And you think, okay, great, like cheap and cheerful, and I can run anything on here, and it's super fast. 1 second transactions, 80 million gas per block. The problem is that from a very practical and real perspective, we run into time and space and cost considerations. So time in the sense of how long you can, the ability to propagate more and more data around the internet reliably, right? The space being how much fast SSD storage you need to be able to store this data, and the cost being around really CPU time to be able to process these transactions and blocks. So if we go up to 48 or 64 megabyte blobs quickly, does that mean that I can no longer run an Ethereum node on my MacBook, right? Or on my MacBook Mini? Do I then need like serious, server hardware? Do we give up on home stakers, home validators, et cetera, et cetera? So I think that's the other, another dimension to that equation as well.
Awesome. Thank you so much. And how about like the talks on combining L2's blobs together and then like submitting that? I recall there was some discussion around that, but I don't really remember how it went.
Yeah, it's a good question. I don't have probably the latest context on that either. I can definitely see something like that happening though. I think that with this proliferation of L2s, that they, and limited block space, L2s growing faster than the block space, that some of them probably will bind together to figure out a way to share blob data.
All right, awesome. One last chance, if anyone has any more questions. If not, then thank you, Jeff.
Thank you, everyone.
All right. Well, that was a great session. We had submitted a blob live, and then and also sadly the last session that we have, on the stage. I want to thank all of you guys for staying here and then listen to all the talks and then really joining the conference and chill with us and hang out together. A couple things just to finish us off. We have happy hour, just gonna start very soon. I think right now is almost 4. So the happy hour will start at 4 next to the music stage. Hopefully you guys also enjoy some of that chill vibe right there. And I think also just join there. I think that sort of concludes our conference. Hopefully you have enjoyed. For people who have the ticket to the closing party, there's some detail. There should be some details that you already have received. If you don't know, ask me. I'll be happy to provide it to you. But in any case, thank you for joining us in ETH Taipei 2025, and see you guys next year.